little. So this type of event lets people know that there are people that look like them, and there is a way to get into top institutions like Imperial. So for example, this event focused highly on advertising the PhD scholarships that are available and also the master's scholarships. I think that was really important.
I feel like mentorship and programs like this is something that is very essential. If you really want to move far and also move fast, you need to listen to people's way of navigating through and being better. And I'm really, really grateful to be here today and be able to attend the session all through. I can't say thank you enough. Thank you so much.
The Black Graduates Career Conference has been designed to empower and to recognise and to provide a space and a platform for black graduates or black undergraduates to give them opportunities to think, what next?
It's really refreshing to kind of come to a space and see industry leaders and pioneers who could look like you, and just to feel represented in an area where you don't really see a lot of people who look like you.
I've been able to horizontally network with my peers as well as vertically network with higher ups and people in places where I want to be.
This year, today, we had over 150 students and many more graduate students within Imperial that come to support us. We have volunteers, we have everyone that really wants to help black graduates going forward. And the whole point of it is to encourage them to think what they're going to do after they graduate.
When you look at postgraduate education, the representation of black people is very little. So this type of event lets people know that there are people that look like them, and there is a way to get into top institutions like Imperial. So for example, this event focused highly on advertising the PhD scholarships that are available and also the master's scholarships. I think that was really important.
I feel like mentorship and programs like this is something that is very essential. If you really want to move far and also move fast, you need to listen to people's way of navigating through and being better. And I'm really, really grateful to be here today and be able to attend the session all through. I can't say thank you enough. Thank you so much.
The Black Graduates Career Conference has been designed to empower and to recognise and to provide a space and a platform for black graduates or black undergraduates to give them opportunities to think, what next?
It's really refreshing to kind of come to a space and see industry leaders and pioneers who could look like you, and just to feel represented in an area where you don't really see a lot of people who look like you.
I've been able to horizontally network with my peers as well as vertically network with like higher ups and people in places where I want to be.
This year, today, we had over 150 students and many more graduate students within Imperial that come to support us. We have volunteers, we have everyone that really wants to help black graduates going forward. And the whole point of it is to encourage them to think what they're going to do after they graduate.
When you look at postgraduate education, the representation of black people is very little. So this type of event lets people know that there are people that look like them, and there is a way to get into top institutions like Imperial. So for example, this event focused highly on advertising the PhD scholarships that are available and also the master's scholarships. I think that was really important.
I feel like mentorship and programs like this is something that is very essential. If you really want to move far and also move fast, you need to listen to people's way of navigating through and being better. And I'm really grateful to be here today and be able to attend the session all through. I can't say thank you enough. Thank you so much.
The Black Graduates Career Conference has been designed to empower and to recognise and to provide a space and a platform for black graduates or black undergraduates to give them opportunities to think, what next?
It's really refreshing to kind of come to a space and see industry leaders and pioneers who could look like you, and just to feel represented in an area where you don't really see a lot of people who look like you.
I've been able to horizontally network with my peers as well as vertically network with like higher ups and people in places where I want to be.
This year, today, we had over 150 students and many more graduate students within Imperial that come to support us. We have volunteers, we have everyone that really wants to help black graduates going forward. And the whole point of it is to encourage them to think what they're going to do after they graduate.
When you look at postgraduate education, the representation of black people is very little. So this type of event lets people know that there are people that look like them, and there is a way to get into top institutions like Imperial. So for example, this event focused highly on advertising
Hi.
PhD scholarships that are available and also the master.
So welcome everybody. I'm Professor Sarah Rankin. I'm in the Faculty of Medicine, and apart from my sort of research and of the Black Inclusivity Catalyst here at Imperial. So obviously welcome to everybody in the room, particularly if you are a member of the public and students that are not from Imperial. Really warm welcome to Imperial. And I'd also like to really welcome anybody that is listening in online. We've had a great response, particularly from people in Nigeria. So a big hello to all you guys. Yes. I would just like to tell you a little bit about the Black Inclusivity Catalyst. This is a project that is funded by UKRI. It is money that comes into the college, and the college chooses how it wishes to spend it, and they have chosen to spend it on this project. So we are really appreciative of that. And what we have been doing with that money is running a series of events over the last 3 years. So we run the Black Graduate Conference, Careers Conference. We run events around Black entrepreneurship, and this is our flagship event for that. And then we run a summer program, and we have students that are from all different universities across the UK that are here today listening in. So those students, give us a shout, please. Come on, do better than that, students, please. Right. Okay, so this point I was going to hand over to Washington, but I think what we are going to do. Now, one of the things we have been doing with students is to help them do presentation skills, because it's the biggest fear of the British public is talking in public, apparently. So each student is going to be presenting one of our amazing speakers. Okay, so we're going to kick off straight away with Faith.
Hello, my name is Fatima Jelani, and I'm currently an undergraduate student in biochemistry at Queen Mary's. I'm going to be introducing Dr. Faith Osier, who is currently co-director of the Institute of Infection Imperial and chair of Malaria, Immunology and Vaccinology. She has been awarded many prestigious prizes, including the Royal Society Pfizer Award, and many more, but we're kind of strict on time, so I'm not going to mention them all. She is currently leading 2 core teams in projects focusing on creating highly effective malaria vaccines, which she will tell you more about in her upcoming talk in Making Malaria History. Please welcome Dr. Faith Osier to the stage.
So thanks a lot for the kind welcome. That was really nicely done. Appreciate it. And welcome to everybody. So nice to see you all. I can see lots of my friends, so welcome. Even those who came from externally, plus those of you who are online that we can't see, I just want to say welcome. So I'm going to talk to you about malaria, and since I can see so many black people in the room, the first thing I'm going to ask is, have you ever had malaria? Anybody ever had malaria? Hey, so I'm with the right crowd. Okay, so you all know, if you've been listening to the news, that there's 2 new malaria vaccines. One's called RTSS, or Mosquirix, and the other one's called R21. That's recently come out from Oxford. Yeah, so you know that there are 2 new vaccines. Yeah, so malaria is going to disappear, right? And you don't need my lecture. We've solved the problem. What do you think? Yeah, it's So the thing is, yes, we do have 2 new malaria vaccines, but the story is far from over. And I'll put it to you that, in fact, innovation in terms of vaccines is only just beginning. The vaccines that we have, we still want to do better. We want to improve the efficacy, yeah, so that as long as you get the vaccine, you're protected, not okay? We want to improve the duration of protection.
You know, when we had the COVID vaccines, how many I got? I won't tell you because it'll tell you my age, right? But let's just say I got a number, right? And why was that? That was because the vaccine provided protection for a short period, and then the protection went down and you needed to get another one, okay? It's the same problem we have with the current malaria vaccines, that they will protect you for a while, but you're gonna need another one, okay? How many people know what the conditions are like in rural Africa when you're trying to manage a cold chain, right? Is it easy? Yeah. And how many of you actually had a big smile on your face when you got your COVID jab? When the nurse put that needle, took it out, you looked at it, and it approached your arm and you tried to move a little bit. Yeah, was it fun? Yeah, and so we also need to improve how we deliver the vaccines. And so I want you to go away knowing that innovation in terms of vaccines, we're only just scratching the surface, and that's why you young people have to move things further to get us to where we want to be. And so my next slide, there's a clicker. Thank you. For malaria, malaria gives us a really good example. I've only got 20 minutes. I'm not going to give you, I'm not going to kill you with it. I'm just going to give you a small dose, enough to keep you awake. The fact is humans can acquire malaria. If you live out in the villages in rural Africa where intensity of transmission is high, that means people are getting many, many mosquito bites all year round. What you find is that the adults become immune and the children become really sick. So I won't even go into the detail of the slide, but what the slide is showing is really that when you're young, under 10 years of age, that's when you have the green line, which is severe malaria. That's the malaria that has you in intensive care. That's the malaria that kills you. But as people get older, they're getting the same infection, but they just have an uncomplicated illness, like a COVID-like illness. They're not in hospital. And as they get even older, even that stops, and people are having asymptomatic infections, which means they've got the parasite, but they're sitting in class like you and me now, listening to lectures, going about everyday life, and they don't even know that they've got the parasite. So what we learn is that it's possible to become immune, and we actually watch it. You see the mums and dads bringing the kid to the hospital really sick, but mom and dad are fine, okay? And that tells us that it's possible to actually acquire immunity to malaria. And then people did a cool experiment. They said, so if people can become immune to malaria, we can take out of them what's making them immune and give it to somebody else. And so in immunology, we call that passive transfer, right? Take out your antibodies, and I give them to somebody else who's admitted to hospital with malaria. And what happened is this is parasite count. It went down. So people who are admitted to hospital had parasites up here. You give them gamma globulin antibody from people who've had malaria many times, and it acts like a drug, and it clears the malaria. And that only happens with people who have experienced malaria before many times. And so the message is it's possible to become immune, and two, you can pass that immunity from one person to another through antibody. And so I don't know if this is gonna show. This is called lack of preparation. This is supposed to be a movie. Do you think it could play? There's a little, yeah. That's it, fantastic. Hey, you guys are the best, thank you. So that's a merozoite, that's the malaria parasite, that's the blood system. So the blue guy finds a red cell that it likes, attaches, orients itself, and then it invades the red cell. And then once it's there, it's at home, it multiplies, it grows, it bursts out of that red cell, infects other red cells, and by this time you're shivering, you're shaking, you're saying, where's that doctor? Right? And so that's the parasite, and that's the cartoon of a parasite. And so in the lab, what we hypothesize is that the antibodies that I told you work. They bind to proteins on the surface of the parasite, or proteins that are secreted from these organelles onto the surface of the parasite at the time of invasion. And so in our research program, we've been trying to understand which of those proteins are important, which are the ones that you can use to make vaccines, what are the correlates of protection, how do you know that your vaccine is working, and what's the mechanism, yeah? There's no, we're scientists, we want to know exactly what's happening. We don't want to say, just take it, you'll be fine. No, we want to know exactly what's going on. And so I'm going to tell you about volunteer infection studies. So all those of you who put up your hand before, when I invite you to sign up for this study, I'm sure you'll put your hand up again. And when you come, what we do is explain to you everything, blah, blah, blah. Yeah, that's fine. And you say, yeah, give me the paper, I sign. And then you put your hand out, and guess what we do? We inject malaria parasites directly into your veins. Okay, so where are the hands that went up before? Anyway, that's what happens in this experiment. We know that the parasites will go to the liver, they do, and then they come out in the bloodstream after about 6 days. But we're there waiting when they come out and monitoring you to make sure you don't drop dead. Yeah, there's no chance you drop dead. We monitor the parasites twice daily, and we're measuring your temperature, blah, blah, blah. We give you footballs, movies, fun things to do while we're monitoring you. But if you become sick, we treat you, and the party stops. You have to go home. But some people, we didn't need to treat them. So we normally take healthy young adults, like the ones I can see in this room. In this experiment, most of them were male because we asked people to stay with us in residential facilities for 3 weeks. We selected people with a range of previous exposure to malaria, and we excluded sickle cell trait. I won't go into the details of that, but here's the outcome. This is the magic. So imagine we've given you the infection, you're relaxing, watching movies. In some people, the parasites came out into the blood and grew, as you can see on that slide. So if your parasitemia went up like this, we had no option. We treated you, and unfortunately, you had to check out and go home. Study was over for you. But then we began to see some magic. We had another group of individuals where we couldn't detect parasites at all. So we monitored them over all these days until the end of the study using a very sensitive method. And these guys had literally chewed up those parasites. We couldn't find them nowhere. And then we had another group in whom the parasites showed up, but they stayed at a low level. So we had a threshold where we were treating. These ones were below the threshold, and they self-cleared. So we did nothing. We just watched until they got to the end of the study and they went home. And then we had a fourth group who were even more interesting. Parasites appeared, but they didn't grow like madness. They just controlled them at a lowish level, still below the threshold that we had set for treatment. And these guys also just hung out with the parasites in their blood. They continued watching their movies until the end, and then they went home at the end of the study. Okay, so how does this link to what I told you? I told you at the beginning that it's possible to become immune, and that's actually what we observe in the community. Here we did the experiment in our own hands where we showed, actually, we're not joking, this immunity thing is real. All these guys were given an intravenous infection, which if you haven't had malaria before, does that to you, and we've got a treat. And these guys just said, no problem, malaria, hamna shida is what we would say in Swahili, no problem. Yeah, they can deal with it. And so that's what we're trying to do with vaccines. We're trying to make vaccines so that when you get a malaria infection, you can just control it. In fact, you can just clear the infection. So then now we come to the lab, and I'm really not going to kill this audience with the details of the lab stuff, but we began to say, what's the immune response in the people who control the infection versus those who don't control the infection? So these are the people who control the infection, and what I just want you to see is that these guys have a lot of antibody This is an ELISA, so very basic lab test. We measured their malaria antibodies. The ones who got sick and we had to tell them, goodbye, party's over, they had the lowest level of antibody. The ones who stayed to the end of the experiment, actually, these guys had the highest level of antibody. So we asked, okay, that's nice to know, but what kind of antibody is it? And here we're looking at IgG, so one of the types of antibodies that we make. We've got 1, 2, 3, and 4. Very clean, simple answer. Most of the antibody was IgG1 and IgG3. And this type of antibodies are cytophilic, which means that these antibodies are not lone actors. They engage cells. They're cytophilic. They talk to cells and they tell cells, hey, there are bad guys here that we need to sort out. And so there's a joint effort between the antibody and the cell. And so these are the assays that we did. Again, I won't go into it because I can see so many immunologists in the room. But these are different assays that I'll give you one example here. This is a complement assay. Here's a C1q molecule of complement. Here's the merozoite I showed you in the movie. In between is the antibody from the volunteer. And what this experiment is asking is whether this engagement is leading to destruction of the malaria parasite. And this was work done by Kenyan students. We were in Heidelberg at the time. So when people say we're not doing science, it's a lie. Here we are. We are doing science. These guys all wrote their PhDs doing that. And here's the data. And again, I'll keep it simple. For all these assays, which are investigating the interaction between the antibody and the cell, we found big differences between people who controlled their malaria, so they were not treated, versus people who were treated, really significant. Papers are all published. I haven't updated that, but really very nice, very clean results. If you draw the same data as a forest plot, when it's at 1 here, hazard ratio of 1, it means there's no difference between your groups. Everything we've measured in my life before was just around here, but in this experiment, we had fantastic results. These are all the cartoons I showed you before at the top, and as you can see, the effect size is really huge. The confidence intervals are small, except for the one assay that just looks at blocking antibodies. But all the FC assays, which look at the interaction between the antibody and the cells, really strongly significant. So when you measure things one by one, that's okay, but in the body, everything's hanging out together. So we looked at the breadth of the response, and we're technically just adding, if you've got 1 or 2 or 3 of those cartoon pictures I showed you, do things get better? The answer is yes. You can see if you have 4 or more, that's associated with a high level of protection. And it correlates, again, very nicely with the amount of antibody that you have. Yeah, so this is your breadth, which is the same here, and this is your antibody binding. And the more antibodies you can bind, the better the breadth. So what I've told you is that we used an unusual model that I saw your faces. Most of you were quite worried. Human challenge. It's scary when you hear about it at first, but in fact, in Africa and places, people get malaria while they're sitting out in a pub having a drink. So it's not really that unusual. But in our hands, it was really powerful. We're really able to demonstrate that it is possible to become immune. We were able to identify what's there in immune people that's not there in non-immune people. And here we had just the IgG to the merozoite. I showed you that the cytophilic ones were the ones that were important, so the ones that were talking to the cells, and that these mechanisms strongly predicted protection, while the blocking one didn't, and that the breadth, when you add everything together, that was in fact the best correlate. And so because the time is short, I will not tell you too much about how we're advancing it. I just wanted to show you one other nugget of innovation. This is a chip that we made while the group was in Kenya. So these are all the people. Some of them are here in the room, so find them and ask them about it. But in fact, this is moving the next step forward. We've got individual merozoite proteins that we've printed on that chip, and we can use it to interrogate the slides, to interrogate the samples from the study that I showed you, so that we move from the merozoite. Remember the whole blue thing? That thing's got about 800 proteins. So we can't make a vaccine with 800 proteins, but we can go down to specific individual proteins, and that's what the chip allowed us to do. So when we finished that, we were really excited, but in fact, there's more work to be done. Now we understand the type of antibodies that we want. We've been funded by Wellcome to study the qualities of these antibodies. This is the bit that binds the parasite. There's other interesting things that happen on the FC end that facilitate the mechanisms that I showed you. And so we're working with partners here at Imperial and at other universities to try and understand that better. But also on the back of that, we've become involved in manufacturing and helping to catalyze manufacturing in Africa. We spoke about COVID. I was living here getting lots of COVID jabs, but my brothers and sisters who are in Kenya hardly got any vaccines. And that was played out for so many people. And so we've got a program of work where we are trying to support small-scale vaccine manufacture on the continent. Because of time, I won't tell you, but you can see me after. We can talk about it if that's of interest. So here's one example where we're looking at mRNA manufacture. And the project is structured that we have a UK partner who's providing the technology, the know-how, and we're doing technology transfer to people on the continent. And we want to end up with the active vaccine, active drug substance made on the continent in Africa. And it's just a contribution towards a big problem, but you have to start small and get somewhere. And just to close, here's another innovation for you to think about. We have a new partnership where we are working with partners in South Africa and in Lesotho to make vaccines, monoclonal antibodies in plants. So instead of growing it in a cell culture system, which is what you're used to here, we can grow it up in a plant and extract it from the plant and show that it works just as well as the other type of vaccines. And hey, this could be a lot cheaper, right? So I think innovation is only just beginning. So lots of people to thank. And the human challenge, I have to say, takes a lot of people. So don't look at me. There's a lot of people behind who do the work. And these are the group. This is the people who did the lab work. So thanks very much.
Good afternoon, everyone. My name is Ashanti, and I'm a recent aeronautical engineering graduate. And I have the honor of introducing Professor Hippolite Amadi. Professor Amadi did his PhD in the Department of Bioengineering here at Imperial, where he is now a visiting professor. In 2023, he was the recipient of the Nigeria Prize. And today, he's going to discuss about his inventions, enhanced neonatal care in Nigeria, and talk about neonatal concerns in Africa.
Thank you so much. Right. Thank you. I'll be sharing my concerns for neonates in Africa. And thank you so much, Faith, for that wonderful talk. But the Africans will have to first of all survive before they face malaria. So I think that if we can make the neonates to live, then we'll solve the malaria problem. But they're all very much important. Okay, high neonatal mortality is one of the crippling conditions that is making the healthcare system in Africa to shake, if you understand what I mean. And here in Imperial College, of course, most of you already know that this university is a very huge university on the global scale. We are number 2 in the world, and we are ranked number 1 in the UK and in Europe. In this university, we push the boundaries of science. We create cutting-edge technology. And you can just say, all right, we are able to take this high-class, super-duper science to do something miraculous for Africa. But here is the trouble. Much as our high-tech can go to Africa, but it is difficult to sustain because the infrastructural base is very, very poor, and the supply chain is very, very poor. So it is very difficult to take a cutting-edge medical technology and make it the main solution for Africa. What this means is that we have to forge a new front to be able to deliver the African unit if we must help. And to do this, to create the science is not a big problem for us here in Imperial. But unfortunately, there will be need to have foot on ground. Because when you create the technology, because you want the technology to be driven by Africans themselves, culturalize it and be able to handle it, then you've got to be there to transfer the technology. And that is a tough bait. So I decided to volunteer myself, because it will have to require a bounce back or bounce forward, United Kingdom, to be able to do this. So in the last 27 years, I put my foot down just to deliver the life that the African unit required. Well, permit me, I'm going to take you on this bumpy ride, because there's a lot to learn. And I hope that it will really be good if I inspire a lot of people, including, especially the younger ones, that we can do it. And one of our recent studies that will soon be published, maybe in the next 1 week, by Frontiers in Pediatrics, is a jury-style systematic review. That doesn't really sound quite normal. Yes, it's actually jury style. We try to reason why, for 32 years since Millennium Development Goal, there have been a lot of effort to push back the neonatal mortality rate, for example, in Nigeria, but it's been quite unsuccessful. So what has been going on? Why was this not a possibility? And we came to a conclusion that actually what we require here is LMIC specific, that's low middle income country specific, or if you like, African specific technologies that will address these key African problems before they can become sustainable and be able to last a long time. So, so these gaps we are talking about, where are they? What are the things creating this problem? So during the MDG, every nation was required to lower neonatal mortality, okay, under 5 mortality rate by a factor of 67%, right? I visited a lot of senior pediatricians in Nigeria, and I tried to find out from them what they thought was driving the high U5 mortality rates. And many of them told me, in fact, virtually all of them told me that the reason was because the neonates were dying in their numbers. By the way, neonates are the tiny babies in the first 28 days of their lives. They were dying in their numbers, and because it was orchestrated by lack of functional incubators, there was no way they could push back the under 5 mortality. So I asked again, so you mean that if incubators were provided, the under 5 mortality would drop and survival will increase? They said, yep. I said, all right. Because they've got no money to buy new incubators, I innovated what we call the reprogramming technique of incubators, which later metamorphosed into what we know today as recycled incubator technique, RIT. I'll be talking about that a lot. So within a short period of time, this became very popular, spread across Nigeria, and many institutions were able to have enough fleet of incubators to assist. And by 2009, we did a national scale impact review analysis, which showed that, yeah, neonates have survived, but yet 1 in 4 would die. And by 1 in 4 dying, there was no way they were going to achieve more than 67% reduction of under 5 mortality. So the question was, there could be some other thing playing out. It's not just incubators. So, but what is it? What is this thing that is playing out? We have to turn to the literature. What have been existing there showed that there was actually a lot volume of death concentrating on the first 7 days of life. And what that means that this thing that I call the F7D, if it is not studied and sorted, forget about the reduction of U5 mortality. And so that formed the next bit of work. What actually is F7D? Now, there are 3 clues we could get from what the WHO publications at the time. Number 1 was that 50% of the death rate were actually being supplied by the neonates. And then you will think that, all right, if 50% of the deaths of under 5 were being supplied by the neonates, and you want to solve that problem, you've got to apply all available resources and research towards the neonates to be able to push back the mortality, isn't it? But it wasn't happening. And then I didn't went further to realize that within the neonatal age, the 4 out of 5 babies that would die are going to die in the first 7 days of life. So we suggest that if there are any resources for neonatal survival, at least 80% of those resources must be channeled towards the first 7 days of life, if you want to make sense out of the whole thing. But I can bet you there was nothing that demonstrated that that was happening. In fact, not up to 5% of resources were going into research within the F7D. So at that time, that was about 2010, I hypothesized to Nigerians, those of them who wanted to listen to me, that, listen, there's no way you're going to make MDG if you did not go back to address this vital information from the literature. I was still a small boy researcher at the time, if you like. So they didn't listen to me. The big boys didn't listen to me. So what I had to do, because I knew I was right, they were wrong, but I couldn't push them. So the best thing I could do was to go to the people that were not performing. There were hospitals that were really very bad. I went to them, I said, would you form an alliance with me? Because there's something that is not being touched. Maybe we will become superstars at the end of the whole thing. So, but let us just try it, innovating new things that were not there, but things that will be affordable. Well, I won some apologists, so we now work together. And what happened was I was able to now, with this group, I began to isolate the various things that were playing out at that particular F7D, and we discovered there were issues with the climate impacting the neonates. There were issues with poor respiratory support, power facility, there was a bit power and facility lighting that was quite poor, suicidal nurses reshuffling, all kinds of things happening for the neonatal care at that stage. Habitual thermal distress, neonatal jaundice, that was so much overpowering, heat physiology and equipment knowledge gaps, dysfunctional facility building. I can go on and on, but I just isolated these few just to buttress what I was talking about. But in solving this problem, each one of them carefully isolated, researched, and of course, peer-reviewed, so that we'll make sure that the solution we are creating was going to be globally acceptable. So we were able to put these things together in some kind of confined or ring-faced practice or application, leading to some of the fantastic results, some of them that have been published, like this particular center where in a particular region, over 5 years, we discovered that mortality had been pushed down from 90% to 4%. I'll still talk more about this, but that's one of the great things that happened over the time. But how did these strategies play out? So neonatal care is a very high carbon footprint application, but all that I was creating was paying attention to how we were going to integrate the global, the United Nations agenda for lowering high carbon footprint. But this has to happen once we are creating solutions for these various neonatal problems. So we have the climatic impact to solve, we have hypothermia, facility lighting, jaundice, and respiratory distress. All these things will have to happen within the framework of making sure that neonatology and neonatal practice was done in such a way that it's going to remove them from the well-known high carbon footprint that the generation of carbon emission that is involved in it. So I'm going to talk about few of the solutions that we created. The recycled incubator technique was innovated in 2003, published in 2007, and by 2009, it was ranked #1 in top 50 recent medical findings on incubators. But here's the interesting thing about RIT. RIT was able to solve the problem of incubator availability across the entire nation. And here, the method was quite simple. What we did was a large contingency of dead, obsolete devices, later the walkways and all the dump sites. We could do one thing, and that was retrieving the shells of the incubators, but recreating the components that operated the incubators by making use of locally available electronic materials and the one that we could source from the internet market. We were able to remanufacture these systems, and for the next 10 years, there will be 7 babies. So it's quite popular, and within a short period of time, it spread across the whole nation. That incubator sorted because with the cost of just 60% of the cost of modern incubator, you could just get one recycled incubator. So many hospitals that could not even afford 3 functional incubators were able to build their fleet base to up to 30 or more. So that really worked. The next thing we have to face is to solve the problem of the climate impact on the babies. They never knew it, but the climate was doing havoc. Because of the high sun intensity, many babies were running hypothermic, and most of the time they were not even able to identify that these babies in their first 7 days of life were unable to manage the high environmental temperature. And because of this, many of them will become hypothermic, and then they will think that it's disease process, and they begin to give antibiotics, and a lot of them died from that. So when we now began to investigate, I said, hey, these babies are not infected. They are simply suffering from climatic impact. So we had to develop or innovate a natural solution by creating a system that would truncate the propagation of heat from the sun, and they use natural convention to establish natural cooling within the nursery building. And when this was tested with existing facilities, we discovered that while incidences of evening fever syndrome, that's what we called it, right? While it was happening in the control room, the lab, which is that room, registered nothing. So that is EFS sorted. Going across the whole country, I discovered something that was quite common. Many of these babies that died at age 7D never saw thermal stability. By that, I mean thermoneutral stability. They never saw it. And I wondered what happened, so I had to devise a technique of plotting the entire temperature profile of their just few days of life. And it was really very disheartening to see stuff like this. Naturally, every person is designed to operate within this safe zone band. So this is physiological temperature that is acceptable, between 36.5 and 37.5. But this thing bouncing up and down is what you see in many of those babies, and many of them died due to thermal shock. And at the end of the day, we have to create a technique that enabled the practitioners to be able to control and keep these babies within the safe zone band. And this is temperature protocol that we had to develop, and that helped to solve a lot of problems. And when you now compare it to in a controlled study, we now discover that the babies that are very, very tiny, who would normally die in their numbers, their death rate was reduced to absolute 0. So it is actually possible for the clinicians to control the thermal effect on the neonates and be able to keep these neonates alive at F7D. So the experience of this center was that they never experienced a single death at F7D, and it pushed down their mortality. I do not have the time to continue going, but I'm going to quickly rush through some of the other technologies that we developed. This is solving the problem of respiratory distress with the Hippolite heart ventilator, because what they were using in Nigeria, as we saw, was what they call improvised bubble CPAP machine. But what this thing does, they did not know it, is they use the bubbled oxygen at room temperature, and then they pumped it straight into the neonat's lungs, which chills down the neonate, and during perfusion, chilled down blood will take that coldness to other internal organs and shut them down. So there is massive iatrogenic hypothermia that killed these babies, and they never knew it. So the Hippolite heart ventilator did exactly the opposite by ensuring that the babies receive the correct fraction of inspired oxygen, and then the gas is warm to body temperature, making these babies to survive. But what I can tell you is that the Hippolite ventilator is not free of charge. I mean, it does not cost you anything like the improvised CPAP, but the cost is so affordable that any African parent who wanted to save the baby can actually afford it. And by the way, that is the science that won me the Nigerian laureate in 2023. So finally, I will tell you about this device. This is the Hippolite ultralumen. This device will clearly show you how the sciences that we created supported the United Nations agenda on climate change. Because if you find a baby who is diagnosed with jaundice, you must naturally bounce that baby from the village to the city. And by doing so, many of these babies will not survive. And even if they do survive, the parents may not even travel because they will have to stay in the city. And you need expert doctors to be able to help the babies to survive, because they're going to do invasive exchange blood transfusion. But with this particular device that we developed, you don't need to go through that invasive technique. This device can work in the villages. It does not use electricity. It does not need a sophisticated medicine or doctors around. You simply put these babies under the machine, and in 18 hours, the babies are discharged, as compared to the 7 days when you're using the gold standard. So it literally reversed the whole thing that you would do to get the baby safe. So I'm going to stop here, but in fact, and what all this means is that for everything that the Africans need to keep their babies alive have been researched, have been sorted. Here you see a newborn center in a village, everything running on carbon-free applications and having very high success rate of 100%. And the same thing for a referral center size facility where mortality has been reduced from 90 to 4. And most of the things they are doing running carbon-free facilities. So I think that this is African solution researched and sorted. Thank you for listening to me. I'm sorry I took more of the time. Thanks. Sorry.
Thank you. Brilliant. Real sort of engineering approach there. Love it. Could people move across, please? We've got people sat on the stairs, so it'd be great if they could have seats. Thank you. And just to introduce our next speaker.
Hello, everyone. I'll wait for you to settle down.
Yeah, I'll try. Not literally.
Hello, everyone. My name is Ochieng, and I am a chemical engineering student here at Imperial. And today, I would like to introduce Professor Mike Templeton. He is a professor in the Department of Civil and Environmental Engineering here at Imperial, where he holds the Oxfam and Water for People Royal Academy of Engineering Research Chair in Global Sanitation Technology. He's also co-chair of Imperial's Global Development Hub, and the title for today's talk is Sustainable Sanitation for All. So please help me welcome Professor Mike Templeton.
Thank you. Let's go. All right, thank you for that lovely introduction. So I was joking with Faith that this kind of feels like it's becoming a competition. What's more important, malaria, infant mortality? I'm going to convince you it's about water and toilets. Those are the most important things. The truth is, they're all important. I'm not from Africa, I'm from Canada. But most of the research I do is in partnership with amazing African researchers and with communities in Africa who need access to improved water and sanitation. So if there's one message that you take from my presentation, if you don't listen to anything else, I guess remember the word partnership, because I think partnership is the key theme throughout the whole presentation. And I mean partnership not just internationally with researchers based in Africa, but also across disciplines and also with people outside of academia also. So if that's one lesson you take away that maybe you can apply to your own work, then I feel I've done my job. So we hear these big numbers about how many people in the world don't have access to water and sanitation and how many people are dying because of preventable diarrhea. And it's really hard to picture what those numbers mean. But it's very sad, though, that about the equivalent, for some reason, North Americans always talk about things in school bus equivalents. But over the course of this event, about 2 school buses full of children under the age of 5 will die because they don't have access to adequate water and sanitation in some of the poorest and most marginalized communities of the world. And many of these are in sub-Saharan Africa. And you've all heard of the Sustainable Development Goals. There's SDG 6, which is all about improving access to clean water and sanitation. And everybody in the world is supposed to have access to sustainable water and sanitation by 2030. And currently, about 3.6 billion people don't have access to safely managed sanitation. And it's actually true now that more people have toilets that are not connected to sewers compared to those who are connected to sewers. And again, unfortunately, many of these people who lack access are in Africa. And sorry, some difficult photographs here, but unfortunately, this is the engineering system that is failing around the world. The fact that if you're not connected to a sewer, you need to have some kind of a sustainable toilet, which is going to be safe to use, which is affordable, desirable, functional. And then you have to have some way to empty that toilet eventually, because every toilet's going to fill up. There's no silver bullet toilet that never fills up. And then you have to have some way to safely dispose of that waste, or maybe even to recover value from it. And unfortunately, in lots of places in Africa and other parts of the world, you have toilets that are overflowing, which are no longer usable. They're disgusting, and nobody really wants to use those toilets anymore anyways. If you have people who are going to empty the toilet for you, they have to do it without any kind of protective equipment. And it's a very degrading job from a social perspective also. And then even if you can empty the toilet, quite often that waste ends up being reintroduced into the environment, which sort of cancels out the whole purpose of having toilets in the first place. So I'm going to give you a few case study examples of research we've done with partners in Africa to try to make different parts of this system work better. And one idea that we had a few years ago was to come up with this thing called a tiger worm toilet. And so the idea here is to come up with a way of adapting a basic pit latrine design so that you could have tiger worms, which are composting worms. They're the most common type of composting worm in the world. There are many in Africa also. And try to make the conditions appropriate in the latrines so that they make compost, they really eliminate the smells, they mean that the toilet doesn't fill up as quickly. And when you do have to empty it, it's just compost material, so it's not raw human feces or excreta that you're emptying. So this was funded by the Gates Foundation. It was a really interdisciplinary project. We had a lot of social scientists speaking to the desired end users. Is this something that you understand, that you would support, that you would want to invest in? And also many non-academic partners like NGOs and government ministries, and also directly with communities, as I said. So the work initially started in India, actually, and whenever you come up with an idea as an engineer, you have to start with some lab experiments, so there's a bit of data collection. How quickly is the toilet filling up with the worms or without the worms? And then at the same time, talking to end users and getting their feedback. What do you like about the idea? What don't you like about the idea? How can we make it something that you're going to be happy with? And finally, you come up with a design that looks like this, which looks like a normal pit latrine, really, where the worms are in this container down here, and the user really doesn't have any direct line of sight or any kind of contact with the worms. Probably doesn't even know that there are worms down there treating the waste. So the idea started in India, but now it's actually spread around the world, including many countries in Africa, and I've listed 3 there that I know it's been very successful with poor communities. And we haven't reached the numbers that Hippolite mentioned there in terms of his neonatal successes, but the technology is growing in popularity, and we're talking about tons of waste being treated every day. And importantly, it's also a much safer technology, or much cheaper technology for households to use compared to existing low-cost latrines. And so we published a paper with partners in Sierra Leone and Oxfam, which was all about the lessons that were learned from a major Oxfam project in Sierra Leone. Again, what were the reasons for failure of the technology? What were the things that people liked about them? And how can we optimize the design? Another research case study is looking at the fact that when we're trying to address Sustainable Development Goal 6, it means we have to install a lot of toilets for people. But we have to also be very careful about where the groundwater is in these areas, because quite often the groundwater is a source of drinking water through boreholes. And there's a lot of research on microbial contamination of wells, but less research on how chemicals move through the subsurface and get into wells. And so we did some research specifically looking at nitrate, which is a human health hazard if it gets to too high a limit level in your drinking water. And it's actually quite hard to remove cheaply from water once it gets into water. So this was a study that we did with partners in West Africa. I got to practice my French when I was out there, because this was in Senegal, Cote d'Ivoire, and Benin. And we came up with a model for how you can model, depending on where you put a latrine, what's that going to mean in terms of the rate of nitrate pollution of groundwater nearby. Another research case study to do with water and sanitation that we're working on is looking at this disease called schistosomiasis, which is a really hard word to say. Some people call it snail fever, or bilharzia is another word. And it's a disease that's very common in Africa, in sub-Saharan Africa. There's about 200 million people globally who are affected by schistosomiasis, and about 90% are in Africa. And it's spread from people who have the worms in their intestines. They shed eggs, which infect an intermediate host, which is a snail in freshwater bodies. And then other people get infected by water contact. So it's not a parasite that you ingest. It's one that bores through your skin if you're swimming or fishing or doing laundry or other things in a contaminated water body. And it's something that we know that even the ancient Egyptians struggled with. So it's something in international development that we call a wicked problem, because it's something that's been around for millennia. And it's really a problem that requires different types of interventions simultaneously to try to eliminate the disease. And so we were really lucky from 2017 to 2022 to work on again, a very interdisciplinary international project with partners in Ethiopia and Tanzania, and also the Natural History Museum next door here to Imperial. And we worked with snail biologists and engineers and social scientists and synthetic biologists, and looked at what is the infrastructure and also the softer types of interventions, not just engineering interventions, to try to stop transmission of this disease. And a really neat paper that came out of that was also on the social science side of things, looking at how do you communicate the risk of contact with these water bodies effectively to communities in endemic regions. And we worked with a charity called Acting for Health, who actually use theater-based behavior change techniques for trying to really explain to people in their own understanding, in their own language, in a way that they actually feel is a good way to communicate to their community members and colleagues, to try to improve uptake of schistosomiasis control measures and also understand the risks better. So again, that was in Ethiopia and Tanzania. And this is a picture that one of my PhD students took in a school in Ethiopia. And it sort of highlights the problem that when you're addressing water and sanitation, you're not just addressing water and sanitation. This little girl, when I saw this picture, I thought she was maybe 7 or 8 years old, but she's actually 12 or 13, I think. And her growth has been stunted because she has anemia and she has a number of intestinal worms which have affected her growth. And a lot of that was because of the poor hygienic conditions in her school. So this is the school that she's attending in rural Ethiopia. And so something else that we've looked at is specifically in schools, what is the relationship between the quality of water and sanitation in those schools and hygiene and schistosomiasis, but also other types of helminths like hookworm. Maybe unsurprisingly, and as we expected, there are really important links there which highlight that quite often we focus on drugs as a way of treating these illnesses, but actually if you improve the water and sanitation, that's a really important preventive measure to reduce these diseases in kids. And we published a paper recently in one of the new Nature portfolio journals, which was all about looking at, well, what are some success stories of how people have actually implemented sanitation in schools and managed to keep the toilets clean on a sustainable basis. And what does that mean in terms of the improvements in the child health in those schools? So again, when I talk to engineers, I quite often tell them, you're not just building something, okay? You're building something, okay, that's your job, is to build something. But it has a lot of benefits that go way beyond what you're building. In this case, child health is directly related to that technology. And then one last example, I think, is some work that we're doing with partners in Ghana. So you're going to hear from Sam later on today. And this is about looking at the sources of water that people use in urban centers in Africa. And there's this growing trend in Accra, but also other cities in Africa, for people to rely more and more on what's called sachet water. So this is drinking water from a plastic bag, 500 ml plastic bag. And increasingly, a lot of communities are relying on this as their primary source of drinking water. And so the question, besides all the plastic waste that it creates, the other question is, well, how resilient and sustainable is this for the future? And so we've been looking at census data, which has shown a really big increase in people having to use sachet water, or even in some cases choosing to use sachet water over other sources of water. And so again, you're going to hear from Sam later on, but this research was based in Ghana. Jacob was the PhD student who led that at the University of Ghana. And we looked at, again, across an urban area, what are the different sources that people are using for their water, and how does that relate to some socioeconomic characteristics? So for example, do rich people have more choice in terms of the water source that they access compared to poor people? And how much does it cost in different parts of the city, for example? We also looked at what are the different brands that people are using across the city, and how safe maybe are those different types of water sources. And sorry, one last example, I think, which is I'm also involved in a lot of research, sorry, not research, but education-focused activity. So this is an example from the Royal Academy of Engineering. They have a program called Higher Education Partnerships in Sub-Saharan Africa. And here we worked with Fora Bay College, which is in Freetown in Sierra Leone. And we've helped them to develop a new water quality testing lab and improving their facilities for IT education. And also developing women in engineering programs and doing remote lectures. So I think there's a lot of work also to be done outside of research, also in terms of education and capacity building. And finally, to mention at Imperial, in the introduction, this Global Development Hub was mentioned. So this is a fairly new initiative at Imperial, which is looking to be an umbrella for all of the Sustainable Development Goal related work that we're doing at Imperial with partners in lower middle income and least developed countries. So it's chaired by me and Sarah, who's a professor of HIV and communicable diseases in medicine. So one engineer, one medic. And if you're interested in finding out more about the hub and some of the programs that we run, like seed funding for new partnerships in Africa, you can visit the website there. And that's it, I think. Thank you to my exceptional African partners.
Brilliant, thank you, Mike. That's excellent. Right, we're on to our next talk. It's going to be online, but Christian's going to introduce it.
Good afternoon, everyone. My name is Christian Kabueze. I'm a mechanical engineer graduate at Staffordshire University, from Staffordshire University. I would like to introduce Professor Julie Makani, who has been a provost professor in the Department of Hematology here at Imperial. Professor Makani is a physician scientist in the Department of Hematology and Blood Transfusion at Muhimbili University and Muhimbili National Hospital in Tanzania. She will talk about research and practice which focuses on finding a cure for sickle cell.
Hello, everyone. So thank you very much for the introduction, and thank you, Professor Sarah, for inviting me to speak. I'm speaking from Muhimbili University in Tanzania. So I'll be speaking about, hang on. So I'll be speaking about finding a cure for sickle cell disease. The slides don't seem to be moving. And this is work that has been done by many, many people in many institutions and in many countries. So just to name a few, Sickle in Africa Consortium is a consortium that's been running for the past 8 years. And we had a data coordinating center in South Africa and a clinical coordinating center in Tanzania. And it involves sickle cell patients, personnel, researchers, healthcare providers from 8 countries. We also collaborate with institutions and organizations in Africa as well as outside Africa. But most importantly is the work that we do very much involves and is in partnership with patients who live with sickle cell disease as well as healthcare providers and providers, family members of people with sickle cell disease. Now, when you think about what would be the 3 characteristics of a model disease for genomics and human genetics, these are 3 are thought to be what are the characteristics. So the first is that the disease has to be highly heritable. Either the coding mutations have a large effect, or it's relatively easy to transfer the genetic mutation to cellular and animal models in order to conduct mechanistic studies. So that's the first characteristic for a model disease. The second characteristic is that there has to be an unmet medical need. The third is that with this condition, there has to be limited interventions. So sickle cell disease is known as the first quote-unquote genetic disease. In 1949, Linus Pauling and his colleagues were able to describe accurately the genetic basis of the disease, and they were able to describe the molecular pathology that occurred in sickle cell disease. So it's known, or it's referred to as the first genetic disease. So it's highly heritable. The second thing is that sickle cell disease has an unmet medical need. The WHO, the World Health Organization, has recognized sickle cell disease as a problem of public health significance. And that is because it's common. The birth prevalence of sickle cell disease, the number of children born every year with the condition is over 500,000. And the majority of these patients are born in sub-Saharan Africa. When you look at the population prevalence of sickle cell disease, again, these are estimates. It's estimated that over 8 million people are living with sickle cell disease across the world. 5.7 million of those are in sub-Saharan Africa, where the burden is greatest, as well as in India. In the UK, it's estimated that there are about 18 to 20,000 people with sickle cell disease living in the UK, predominantly in England. Now, so it's common, many children are born with it, and many people live with it. The second thing, in terms of characterizing an unmet medical need, is that it causes significant morbidity and mortality. So it causes significant complications leading to ill health as well as death. If you have sickle cell disease or sickle cell anemia, which is the most common form of the pathology, if you're born with sickle cell anemia and you live in Africa, you stand a 10 to 50% chance of surviving to the age of 18 years of age. If you have been born in Jamaica, US, and the UK, your childhood mortality is significantly lower. And this has been confirmed. This is all relatively old data that has come from individual studies, but more recent studies have been able to demonstrate that mortality is much, much higher than previously estimated. And the third aspect is that sickle cell disease has limited interventions. If you identify children at birth using either newborn screening or early infant diagnosis, you effectively manage infections, particularly pneumococcal infection. You can reduce mortality in the first 3 years of life by more than 70%. So we know that this is something that works. Newborn screening and comprehensive care. If you look at the two lines down here, and these are adults and young adults and adolescents and adults, you'll see that really mortality has not changed. And this is an old slide from 2009, and the mortality hasn't really changed much globally from sickle cell disease. So there are limited interventions. Bone marrow transplant and gene therapy, which I'll talk about later, are curative therapies that are available that we need to think about in terms of as an option. Now, when we started working, as mentioned, I'm a physician scientist. When we started working on sickle cell disease, we started off over 20 years ago at Imperial University. And at that time, with welcome funding, we were going to start and just do a very simple clinical descriptive study to identify what are the main causes of illness and death, what are the things that we can do in our setting to reduce morbidity and mortality. This was 20 years ago, and we subsequently have been able to identify over 5,000 individuals with sickle cell disease, making this one of the biggest single center cohorts in the world. And we've been continuously following them up for over 20 years. But as you know, life happens. You've got a plan, you know, this is what we're going to do, this is how we're going to do it. And then you suddenly realize, actually, sickle cell is curable. In 2017, Jean-Antoine Rebier and Marina Cavazzana and the group in Paris, France, were able to demonstrate very effectively that it is possible to cure sickle cell disease using gene therapy. As you can imagine, a year later, we had a very simple question from the government of Tanzania. How do we get cure for sickle cell disease to individuals with the disease in our country? Now, you'll hear about this a bit later. The cost for transplant estimate is between $50,000 to $100,000 in India. In the UK, in the US, it's between 200 to 250,000 pounds. Gene therapy recently been approved. We're looking at a price tag of about $1.8 to $2 million. So we thought this is just too overwhelming. We can't start looking at these things. In 2019, at the Grand Challenges meeting in Addis Ababa in Ethiopia, the NIH and the Gates Foundation committed $200 million to gene and cell therapy for HIV and sickle cell disease. We thought this was fantastic, but there was a huge response. How dare you think about curing sickle cell disease when you haven't even established newborn screening, when you haven't even established access to hydroxyurea? Why on earth would you look at a curative therapy for the condition? We stepped back and we had to balance out these concerns or these perspectives and the perspectives that we were getting from our governments and from the patients themselves. Patients were asking for cure. If we were not going to provide it for them, they were going to go out of the country and they would get transplant or access to gene therapy, whether we liked it or not. As a result, three countries in Africa, this is Nigeria, South Africa and Tanzania, established bone marrow transplant services. And this is a photograph of 3 of the children who were first transplanted and cured of sickle cell disease using bone marrow transplant or hematopoietic stem cell transplant in Benjamin Mkapa Hospital in Dodoma, which is central Tanzania, under the leadership of Dr. Stella Malangai and her colleagues. And then in 2000, have been licensed, 2 in the US and 1 in the UK, have been approved for treatment for sickle cell disease. So all of a sudden, what we thought and what the narrative that we were taking forward was changing. We initially, when Nasra and her brother Ramadhani, when they were diagnosed with sickle cell disease about 15 years ago, the narrative then was there isn't a cure. All of a sudden, the patients are coming to us and saying, how do we get the cure? We can't turn around and tell patients that, well, you can't get a cure because you live in Africa, or you can't get a cure because you can imagine what will happen. They will get on a plane and they will go to a country where they can get the cure. And this is precisely what happened with Nasra and Ramadhani, where they were able to get bone marrow transplant from their mother as a haploidentical donor to give them transplant. So we had to kind of step back as a country, as a group of people, stakeholders, and say, what are we going to do? We know that hydroxyurea is cheap. We can get it so that it's accessible. Yes, there'll be issues. We know the limitations of bone marrow transplant with regards to getting access, a matched sibling donor or otherwise. And what we are seeing, or what the publications are showing and the research is showing, is that it is effective to treat sickle cell disease using ex vivo gene therapy. But the future really is in vivo gene therapy, and we've seen it. It works. In vivo gene therapy, which is like a vaccine, an intramuscular injection in hemophilia, and it works. So for us, we were looking and thinking, instead of thinking about going through the normal options of treatment, where we're saying, okay, first of all, have a disease-modifying agent or medicine like hydroxyurea. Then for a few of you who are able to get transplant, you will get transplant, participate in ex vivo gene therapy. Is it possible for us as a country, similar to other countries in Africa, where instead of looking for improving telecommunication, we just leapfrogged, and from drug treatment, we go directly to in vivo gene therapy, similar to the use of mobile phone technologies and how that leapfrogged the communication in Africa, including fintech and other items. And so our approach was to say, we have to do both. What we started 20 years ago, we need to think about how we consolidate that now, but at the same time, how do we make space for curative therapies? And here we use the approach that we've been using for the past 20 years, is an integrated approach, where the first thing is we work very closely with the patient community. We ensure that rather than say we'll do research first and then translate the research into practice, we said that it'll take us longer, but we will approach, or we will improve all the 4 areas. We'll improve healthcare, we'll conduct research, we will train scientists, healthcare providers, policymakers, and we will participate or engage with advocacy at high level with presidents and heads of states, and at community level. This is something that we need to do. And as you can imagine, it requires many people to be committed for a long period of time and to really just do this. As a clinical scientist or a physician scientist, my focus was looking and trying to understand what are the causes of anemia in sickle cell disease. We know that it's a hemolytic condition. We know that there's an element of reduced production of red blood cells. But what are the genetic factors that influence sickle cell disease? When you look at research that has been done, very little research had been done in Africa. So the first thing that we started doing as a group was to say, what are the clinical and descriptive epidemiological characteristics of the patients that we're seeing at Muhimbili University in Tanzania? And we were able to describe anemia was common. It was associated with increased risk of mortality. We saw that there was a significant difference during steady state and acute stage, and we realized that there was relatively heterogeneity within the sickle cell population when it came to anemia. So although sickle cell anemia is quote unquote the same disease, but it's very different for individuals, between individuals, and for individuals at different stages of their lives. The second thing that we did was to say, we know, we as scientific community, we know that the presence of fetal hemoglobin, which is a type of hemoglobin, really is a significant modulator of disease. High levels of fetal hemoglobin are associated with low severity or very little severity of disease. And so when you looked at the genetic factors that are associated with the diversity of HbF in sickle cell disease, we know that it's a genetic modulated factor, but we know only 20% of that, and that's determined by BCL11A, HbS itself, as well as XMN1. So we looked and we said, well, how do we conduct genetic research? And I think this is where we were very fortunate as part of H3 Africa, which I'll talk about a little bit later. This is an initiative that was started close to 15 years ago now, where we were able to look and establish the fact that we can do genomic research in Africa. And so work led by Dr. Siana and Dr. Siana Nki and Dr. Florence Urio, we were able to conduct the first GWAS study, genetic association study, genome-wide association study on fetal hemoglobin in Africa. And we were also able, with work that was led by Dr. Florence Urio, she was able to identify a fourth genomic factor that is associated with HbF. This is important because this, first of all, validates the HbF genomic factors, but it also identifies new factors that could be targets for interventions. So we worked, again, this is work by many people over a long period of time, not just in Tanzania, in the UK, in the US, where we're able to describe accurately the genomics of fetal hemoglobin, as well as what are the differences and similarities of these factors. But this was not enough. We then had to address the issue of what we termed advanced therapy. When we talk about advanced therapy, in addition to optimizing and making sure as many individuals with sickle cell disease have access to hydroxyurea, but we needed to improve access to blood transfusion. We needed to improve the possibility of getting bone marrow transplant, and we needed to participate in genomic research. Fortunately, we were not starting from scratch because Dr. Siana, H3 Africa, had established genomic research capacity in Tanzania and in many other countries in Africa. We collaborated with colleagues funded by the Gates Foundation from University of York, from Uganda, from the US, to look at what are the genomic factors that influence the integrity of hematopoietic stem cells. And we're really pleased that we were able to include Imperial as a site as part of this work. And then work that is conducted again is really looking at basic science research. Again, we wanted to do this from Tanzania, from Africa, with scientists from Africa, is looking and understanding the different factors that influence erythropoiesis, which is the production of red blood cells in sickle cell disease. In addition to this research, work led by Dr. Daima Bukini was to really engage patients. What are the things that are important for patients? We can't assume as healthcare providers or as scientists that we know best what is for patients. And patients turned around and said, yes, we would like to understand a bit more about advanced therapy. We would like to have more access to hydroxyurea. And therefore, patients as partners and really modifying our approach to this whole area were an integral part. And then the other bits are really just strengthening collection and processing for hematopoietic stem cells and establishing a biorepository, establishing a registry for HLA typing. And this is work that's been done by Aisha in collaboration with colleagues in Germany with DKMS, where we've been able to start setting up a registry for sickle cell patients and their siblings to see if they're matched sibling donors that we can then refer for bone marrow transplant within Tanzania or with other countries. And then strengthening exchange blood transfusion, because this is an integral part, not just of saving lives, but it's also an integral part of understanding what happens to hematopoietic stem cells, how do we collect them, and how do we process them as part of bone marrow transplant. As mentioned during the introduction, I was able to come to Imperial for 1 year as provost visiting professor, and it was really interesting coming back to Imperial, where I trained as an SHO, as a junior doctor, close to 30 years ago. In case you're trying to do some maths, I'm 54. My birthday was on Sunday, so it was very interesting coming back now and looking at the potential that there is at Imperial, and it really is one of those places where. And that was why I went back to Tanzania and said, this is how we want to set up an integrated program, because at Imperial and in other health facilities as well, you're able to conduct genomic research. You're able to look at basic science questions such as hematopoiesis with work that is led by Professor Christina Lo-Celso. We're also able to look at gene and cell therapy, specifically in multiple myeloma, and this work that's led by Tassos Karadimitris, to kind of understand what are the issues that we need to be aware of when we're thinking about gene and cell therapy for hematological conditions. What are the things that we can learn for sickle cell disease from other hematological conditions? And I was really very fortunate because there was already work that was ongoing on sickle cell disease at Imperial, led by Dr. Stephen Okoli, who's a senior lecturer in the Department of Immunology and Inflammation, and work by a clinical scientist, Dr. Norris Igben-Merka, who is looking at understanding or describing gene therapy for another red cell disorder, but we can use the knowledge and the experience and expertise that is developed to apply that for gene therapy for sickle cell disease. And then there's amazing work that's led by Sarah, Wayne, and Mary, looking at what are the equity issues, what are the patient-led research questions that we need to address. Now, when I was an SHO at the Hammersmith Hospital 25 years ago, we used to do transplant for chronic myeloid leukemia, CML. Transplant is no longer a cure for CML because there's a medicine called imatinib that is available. But what the Hammersmith Hospital has, what Imperial College Healthcare has, is that they have more than 30 years experience of bone marrow transplant. Here, GGTI stands for Global Gene Therapy Initiative, and this is Adam, and Adam is known as the London patient. He is one of the third or fourth patients or individuals with HIV who had his HIV cured from a bone marrow transplant that was conducted at the Hammersmith Hospital at Imperial. So we've come together as part of GGTI to say, what are the things that we can learn from HIV? What are the things that we can learn from other conditions? What are the basic science questions that we can do, that we can work and collaborate so that we can solve this problem and make sure that it's accessible using in vivo therapy? Remember, what we're looking for is really leapfrogging and providing in vivo gene therapy for patients with sickle cell disease. Now, in order for us to do that, it cannot be solved by one government, by one individual, or by one group. It's something that needs partnership. It needs policy issues. It needs partnership in academia, in science, and in health. And we've been working, many people over a long period of time, with governments, with health agencies such as the WHO, the UN General Assembly, financing agencies such as the World Economic Forum, and also working with Science Council at the WHO, philanthropy and industry, seeing and exploring how do we engage with the different stakeholders, how do we engage them to make sure that they support the sickle cell population now so that they have access to medicines that and interventions such as transfusion and transplant. But at the same time, how do we make sure that we, as people working in Africa with the biggest population of sickle cell patients, how do we ensure that we are part of the process? Again, being in the UK has just been really very helpful because we were able to participate with government and engage with governments at the all-party parliamentary group committees on sickle cell disease, chaired previously, I think it has to change now, chaired at that time by Janet Darby. Fantastic work that's being done by the Sickle Cell Society, working with national agencies, ministries of health, ministries of education, ministries of science and technology, both in the UK, in Africa, and in other countries in Africa. And then an interesting phenomenon has happened is that realization, and this was accelerated by COVID, where it was realized, and for us as a physician or as a specialist in internal medicine, for me, it was just really something that we had been trying to say for a long time, that we need to strengthen specialist services. I'm almost done. So we've been engaging with industry, philanthropy, and with science academies. So ultimately, the question is, how do we find a cure for sickle cell disease? And it really is an issue of time. We want to make sure that in vivo gene therapy is available sooner rather than later. And the focus really of the work that we're doing is really centering it around people. We're not doing science just for the sake of science, but we're doing science for the benefit of humanity. And this was a quote from Francoise, who received the Nobel Prize in 2008. So thank you very much for listening.
Okay, thank you, Julie. That was great, and it gives us hope for the future in terms of the treatment and cure for sickle cell, which is going to be incredible, especially the sort of in vivo genetic engineering. Right, Prince, no, not Prince. Right, hello, come on. We're running out of time.
Yes, we are.
Yeah. Excellent names.
Firstly, I'd like to say welcome to everyone. For my folks back home, I'd like to say karibu. My name is Alphonse Ochieng. I am a student who studies at Goldsmith University, computer science. And it is my honor today to present to you, or introduce, Professor Washington Ochieng, who is currently the head of the Department of Civil and Environmental Engineering at Imperial, and chair in positioning and navigation systems. In addition of running large departments and research groups, he has played a major role in policymaking in both the UK and Africa. He is a fellow of the Royal Academy of Engineering and received the Howard Spencer Jones Medal for his valued advice to policymaking and pioneering research in safety and critical navigation and positioning systems. He is a trustee of the Science Museum and the president of the Royal Institute of Navigators. In 2023, he received the Elders of Order of the Burning Spear Award from the President of Kenya, and this year he has received the award of a CBE by King Charles III. He's going to talk to us about engineering safety. Thank you.
Thank you very much. My namesake, he's also Ochieng, which is great. So a very warm welcome from me, and thank you very much for coming. I know that I'm standing between you and refreshments, so I'll try to bring us back on time. Let me say before I say a few words about the presentation that this Africa Innovates is a great initiative, thanks to Professor Rankin and colleagues. And we are shining a light on Africa, which is a great thing in the sense that also what I want to talk to you about is about the world. We don't want any part of the world left behind, and that will be basically what I'll be doing here. Wonderful presentations so far, looking at different aspects of what I'm going to talk about, but I'm going to look at the bigger picture, I'm going to try to recreate how life works, and then within that to see how we can slot in the various innovations that are taking place in those, what I call silos, because you need to link up silos to be able to make impact at the societal interface. So I'm going to talk about sustainability, safety, resilience, all the parameters and variables we may talk about, security and so on. But I'm going to try to encapsulate them in sustainability if I can. And then to say that we need a lot of help from analytics. Yeah? So you have heard of AI and all these things that we hear about. But I would like to be able to model everything, right? That's what I'm trying to do. Put everything into a digital platform. Because if I can do that, I can poke it, I can query it, I can adjust it. And if I can model what exists, if I can model what doesn't exist. So this, what I'm going to talk about, is not a digital twin. You hear about digital twins. I'm going to talk about a digital twin on steroids. That's what I'm going to talk about. Or a digital twin plus, as an idea. So this slide is what I'm talking about. And some people have given me a middle name, Washington. They've removed the Yoto and put in there Apocalypse Now. So I hope this doesn't come across as Apocalypse Now. But what I'm trying to do with this slide is that pentagon that you're seeing there is capturing what I call the threat vectors. So this is where the threats to society emanate from. This is what I'm saying. So if we're talking about HIV and so on, that is coming from the natural biological vector, right? Everything to do with climate change is sitting on environmental. And the worst problem, the worst threat of all is where? It's in the social dimension, right? So if you look at the vectors, and I've been thinking about what is the all-encompassing measure that you would actually use, and I decided to settle on societal resilience. And then the United Nations was warning us that these threats are increasingly happening simultaneously, that by the 2030 we're going to have more than one catastrophe in the world a day. So that's what I'm calling the threat to human continuity. So we are trying to do something about it. And this is my attempt to be able to map the linkages between the threats themselves. I call it the threat landscape. And immediately it becomes pretty complex when you look at it. And I'm saying that if you move that through space and time, you're ending up with some sort of description of how life works and where the threats come from and how they link to one another. It's only when you can do that that these siloed innovations we make will make a big difference societally. Because you may make improvement in one and another, and when you bring them together, they negate each other. So you really need to map this properly, and that's what we're doing at Imperial. You can see the color coding there. Now, if you're finding it a little bit difficult, one of the few things that the United Nations has done really well is this thing called SDGs. So there's obviously a practical issue there with SDGs. So I'm just going to be sharing with you some ideas. No equations, just simple things. Right. So let's think together. If you have a mathematical equation and you put sustainability on the left, and you're thinking, what is on the right? And I'm saying, what's on the right are those things called key performance areas. For example, safety, security, health, and so on. And then you can split them into key performance indicators, KPIs. So those are metrics or measures. And then some of those measures may have targets, like, 1.5 degrees C rise in temperature. So what you're looking at there is an attempt to be able to functionalize sustainability index on the left and all its variables on the right and their correlations. That already is a problem. Because if I was to ask you, is there something that captures them, links them, has the correlation between them? We don't have one. So my problem starts right here. What is the connection between sustainability? What are the metrics and measures on the right? How do you mathematicalize it? Right? And what are the correlations? Because they're not independent. So I start from there. And then I say, well, what are the measures? What are they? So the first thing I do is I look what people have done in the world. And this graph is telling me number of KPIs, then you got the KPIs. It's all over the place, including even ISO. Again, I have a problem. There is no agreed way of measuring how sustainable a city is. Yeah? So we are actually coming up with innovations in little places and so on and so forth. But as a city, at the city scale, we have no way of actually measuring what is happening. Okay? So I'm saying, wake up. We need to do something about it. Okay? So what is the problem? You have these relationships. They're arbitrary. If you say health and if you say security, which one? What's the weight you put on health? What's the weight you put on security? What's the weight you put on resilience? Not clear, very arbitrary. Then you have the consideration of correlations and dependencies. We don't know. Then you have, if you want to do anything to do with mathematics and analytics, you have no chance. Okay? So you've got to solve that. Moving on quickly. So we've done work here at Imperial with our partners who are also in the mother continent. Because I'm interested in improving the world, not just one part of the world. So partners from all over the world, including Africa. And we've come up with these, what we call comprehensive sustainability index measures through the 3 pillars of economic performance, environmental, social, and then you can actually see the sub-KPIs or the KPIs underneath them. These are the things I'm trying to model. I'm trying to put a mathematical formulation to them. So I think we all agree we want to move from the left to the right. We don't want to live on this. We want to go to the Shangri-La on the right. That's what I want. Whether that's for an existing city, whether that's for a new city, where everything we've talked about so far, and we're going to talk about after, can actually represent, can be linked in, and can create what we have on the right. That's what I'd like. And that's good for Nairobi, that's good for Lagos, that's good for Kampala, and so on. Okay? I also want this tool to be able to do retrofitting. So existing cities like London, I need to be able to retrofit, clean them up, make them sustainable, and also inculcate sustainability, security, and so on by design in acquiring new cities. So I'm thinking, by the way, I'm a systems engineer, so I'm thinking, as a systems engineer would do, so I would like to specify some general requirements for this tool, as you can see here. The mathematical engine, which is integrated and parameterized modeling, the tool has to be flexible. It has got to be super fast. I mean, you don't want to wait there for a year for the thing to run. And the visualizer, the interface, needs to speak to different stakeholders, the public, health professionals, engineers, and so on. So these are the general requirements that I would like to use. Then, this is the beast. How am I going to model it? I've listed here everything that I know in terms of what exists analytically. You can see AI, system dynamics, simulated annealing. I'm going to call upon these and more to try to deal with the hyper-complex of putting a city into a computer as a mathematical model so that I can do all the safety, security, and so design and so on. So just to give you a taster that we're dealing with a hyper-complex problem. So who does it? Some of these people have something that kind of, somebody might say, does a little bit. So my students have created this matrix, probably the most important slide, which is telling me, does anything have a green tick from the top to the bottom? And the answer is no. So I say to them, I collect them and I say, yes, we have a job to do. Okay? Why was Imperial invented? To address difficult problems. And that's what we are doing together with our partners. So this tool needs to do a lot of things, including new technology. You hear of driverless cars and so on coming into our cities. How are you going to introduce them if you don't have a platform within which you can test things, you can try things, before you actually go out there to actually put them on our roads? You need this, okay? This is the interface, very simple. Yeah? If you have that in your car on the right, and you're driving on the M25, and it's showing red, which means you're killing yourself softly, right? And then we say to you, why don't you adjust when you travel? That's the most effective way of managing demand for people going on the roads. So you can see, you have some very nice dial indicator, the performance. This is for your dashboard. Very nice, very simple, but very, very effective in terms of how we might live our lives. Then, by the way, I'm coming to the end. I promised to bring you back on time. Functionally speaking, this is what I'm talking about. This is the tool in a functional form. So you got the data loader. It's going to be data intensive. You can imagine representing London in a computer, in a mathematical model. So you can see the data. You can see the engine. This is what we're calling the scenario manager. That's the mathematical engine. You got the measures, and then you've got the scenario manager, the visualizer. Okay, that's what I'm talking about in a functional form. A little bit more, that's what I'm looking at. So if you can see the bottom right, where we put the infrastructure systems, in the UK, we've got 13 critical national infrastructure sectors, of which health is one. So we talk a lot about health. Transportation, energy, communication. That's just a little box on this mathematical platform. Yeah? So the least of my worries. I mean, how do I model the interdependency between or amongst 13 critical national infrastructure sectors, putting that into this model, and it is just 1/100th of the modeling complexity of what I'm trying to do. But then, as life has it, all I'm trying to do is to balance supply and demand, as you can see, the equilibrium model, the supply side and the demand side. But the actual work that goes in there is immense, okay? That's what I'm trying to do. Now, it's very difficult, it's vexed, it's complex, and so on. I don't have time to play the video, but I could have done, because we have already started doing the work, and we already have a version 1 of the model, which is sitting somewhere on the internet. So if later on you want to see it, you can use that link to play this model, and you can see that it is tractable, it's solvable. We have started. Please take a picture of this slide and go onto that link and play it. You will see what we are talking about, how effective that tool can be. Yeah, and it is usable by all stakeholders, including the public. You can play with it. But what I wanted to say is, given the complexity of the problem, I need all the help I can get. So this is kind of asking you to please, yeah, join us so that we can together give the world something that the world has never, ever had. And all of us will be zillionaires once we do this. I can promise you. Thank you very much.
Great. Thank you, Washington. Okay, so I think in the interest of time, we're going to go straight to refreshments, and we will save our questions for the end of the second session. So please, if everybody could be back in the room by 5:15, that would be great. If you go outside, there's teas, coffees, soft drinks, and some sweet things to keep us going for the next session. Brilliant.
a second-year computer science student and roboticist. And it's my pleasure to introduce Angelina, who will be speaking about the African Institute for Mathematical Sciences and Imperial's collaboration with them.
My name is Angelina and I'm not an academic. I'm based at the International Relations Office here at Imperial, and as Jessica has kindly introduced me, I work with partners in Africa and the Middle East, and I will be talking about... Anyway, I will be talking about the African Institute for Mathematical Sciences, here we go, who is one of our strategic partners. So, who are AIMS? So AIMS is a centre of excellence in mathematical sciences in Africa, and at the moment there are 6 centres, and if you look at the map you get an idea of where they are, so they're quite nicely geographically spread. So we've got 1 centre in Senegal, 1 in Ghana, 1 in Cameroon, 2 in Rwanda, and 1 in South Africa. So the first centre was established just over 20 years ago in Cape Town in South Africa by an Imperial alumnus, Professor Neil Turk. And for those of you who are not familiar with AIMS, these are not traditional university campuses. We're talking about much smaller research and education centres. So these are very tight-knit communities. All facilities are available on site. They also offer accommodation to their staff and students. So these are very, very nice and very interesting places to visit. Now, at the moment, they all operate quite independently from each other, but they are all known for their flagship Masters in Mathematical Sciences. Now, this program is available to African students only from anywhere in Africa, and most of them receive very generous financial support. So what this program ultimately does is it makes postgraduate education in mathematical sciences available to the students who are otherwise most likely wouldn't have been able to afford to do that postgraduate degree. And even though the centres obviously focus on mathematical sciences, the research and education they do are applied in a very wide variety of areas. So it's anything from biodiversity and climate science to food security, transport, public health, and many other areas. And we as an institution have been working with AIMS for quite some time now, and in 2020 they became our strategic partner. So just to give you a little bit of context, Imperial works with pretty much every single country in the world, and at the moment we have only 6 strategic partners. So these relationships are incredibly important to us, and what it means is that there is ongoing and embedded collaboration on the one hand between kind of all 4 faculties at Imperial and AIMS on the other hand. And now I'm going to share a very brief snapshot of the things that we have been working on and that we're engaging in at the moment. So one of the areas we're currently focusing is student mobility. So one of the programs we run is the Global Fellows Program. Now, this program is not specific to AIMS. We have run, and we do run it with other partners. We ran it with AIMS for the first time last year in Rwanda, and we will be doing it again later this year at AIMS Ghana. Basically, the idea is that PhD students from 2 institutions come together for a week and they work on global challenges while also developing soft skills such as communication, teamwork, problem solving, creativity, and many others which can obviously be applied in a variety of settings. We have also run the Global Development Hub Fellows Fund, and we did it for the first time this year. Again, that was not AIMS specific, that was an opportunity for PhD students from the least developed countries and the low middle income countries to apply for a research placement here at Imperial for financial support towards a research placement. And obviously AIMS students applied and they got in. We also have consistent internal seed funding towards a variety of projects which are co-designed by academics at Imperial and at AIMS. And these projects take place both in education and research, and we very much encourage our PIs to involve PhD students in those projects as much as they can. And again, just to give you a sort of an idea of the most recent areas in which the projects have been designed. So it's geospatial analytics, epidemiology, AI, machine learning, biodiversity, fundamental mathematics. So again, a lot of very different areas. Our staff also go out to do some teaching at AIM centres, and they also supervise master's projects at AIM. So the master's programme I've mentioned, all students on that programme have to complete a project, and they get a supervisor, and our staff volunteer to do so. And again, some of the most recent topics are machine learning, infectious diseases, statistics, and medicine. We have also successfully applied for large-scale funding towards large-scale projects, What that means is that it normally involves a variety of partners, and those projects last a number of years, and some recent areas include climate change, air pollution, and public health. And finally, I also want to mention the Centre for Doctoral Training in Statistics and Machine Learning. Their funding has been renewed quite recently, and this time they're hoping to engage quite a lot with AIMS, and specifically students at AIMS, both masters and PhDs, and give them an opportunity to develop their professional and academic skills. A lot of information to take in. Right, and so as I've said, this relationship is incredibly important to us, and we very much look forward to developing it in as many ways as we can. And one of the mechanisms through which we hope to do so is the Imperial Global Network. So some of you may know that earlier this year we opened a new hub in Singapore, and we're planning to open 2 more later this year, so 1 in the US and 1 in Ghana. And the one in Ghana will focus on building links with local stakeholders in a variety of areas, and also building equitable partnerships with partners in Africa. Some other objectives include, again, applying for external funding and enhancing our links with the Imperial alumni community and in West Africa. Obviously, such projects involve a variety of partners, and you can see some of them here on the screen. But AIMS is going to be one of the partners who will help us drive this relationship. And I think that is just about 10 minutes. So thank you very much for your attention. Thank you. And if you have any questions or queries, please feel free to reach out.
Brilliant. Thank you so much, Angelina. So who is introducing Victoria? They've gone missing. Okay, so Victoria, this is Victoria Nichols. She's from the Enterprise Lab at Imperial. I've forgotten your official title. It was a management
head of incubation services.
Head of incubation services. Brilliant. So thank you so much for coming here today, and you're going to tell us about the projects that you've got going on in Ghana as well. Thank you.
Thank you very much. Great to be here this afternoon. I'm going to briefly cover a bit about the Imperial Enterprise Lab and what we do, and then talk to you a bit about the collaboration we have with the University of Ghana and the work we're doing there now. I just want to give a shout out to Sarah Ranchev-Hale and Nikki Kelly, who are both in Ghana right now with 7 Imperial founders, which is why they can't be here today to talk about what we do. But they're ones who have absolutely, they're the ones who've really led on this work, and so I can't take any credit, I'm simply standing in. So, what is the Imperial Enterprise Lab? The Imperial Enterprise Lab is all about inspiring and educating and nurturing the next generation of entrepreneurs. And this is something that we have a great synergy with the University of Ghana. We, in the Enterprise Lab, believe that great minds do not think alike, and so you want to bring as many minds together as possible. For the Imperial students and staff in the room, you are very much welcome to come to us. We're in the basement of the Sherfield building. I'll be here at the end of the day. So if you want to come and have a quick chat with me, if you're not an Imperial staff member or student, but you're at another university, the odds are I know whoever it is that is helping at your university, so I can probably make an introduction, which I just did earlier. So without further ado, the overview. We launched in 2016. And it's a dedicated support service, as I said, and it's all about entrepreneurial mindsets, skills, and networks, most importantly. And as of 2022-23, we were given a remit to look after academic staff as well, which is pretty exciting. It's not just me saying we're brilliant. The Guardian did think we were pretty special too. We're currently physically based in the basement of the Sheffield building, and if you've got the grit to find us, I'm assuring you that you've got the grit to be an entrepreneur. Virtually, we have a Slack channel. There's a WhatsApp group for the ventures who are on our mentoring service, and we are also, we go out into the community and do lots of events like this too. So, what's our positioning? We're college-wide. It doesn't matter whether you're an undergraduate in their first year who's never held a permanent job and is just learning about life, or if you're a researcher with decades worth of world-impacting research, we're here to help. We're centrally funded and we're accessible to all. Now we're going to try a bit of interaction. Can you tell me, so thinking about startups globally, if you were to guess, after 3 years, what percentage of startups are still alive and functioning? Any guesses? 5%? Yeah. 10? Did I hear 10? Spot on. Yep. Okay. And what if you come to an ecosystem like London, where there's a lot of talent, there's a lot of money? How many do you think are alive at that point? 25? What else did I hear? 15? 30? A bit down? 50. 50 to 60%. Have you seen this speech before? No, just on it. Okay. Does anybody want to guess what the survival rate is after 3 years for startups at Imperial College London? That would be scary, 100. How do you do this? You're not quite, it's a little bit higher than that. It's 72% at this point. And do you know what this means? It's about the ecosystem. It's about the community. It's about the people we know and bring together. And this is why we work with institutions all over the world. This is why we don't just rely on what we know, and we do know a lot, and my colleagues in the Enterprise Lab are incredible, so much knowledge, but 72% survival rate after 3 years does not come in isolation. And as you can see, some pretty impressive stats there. £556 million raised since 2014. I think this year so far it's something like 85 million that's been raised by startups. Some of those are massive raises, 30, 40 million. Well, only one of them would be that much, obviously. And then the rest are smaller raises. But what we've got is an increasing portfolio impacting the world. And as you can see, there are 189 mentors. This is really important. It takes, as one of them said to me, it takes a village to raise a startup. And what you need are people who've been there before and who know the right people for you to speak to and to get you in contact with. Right. Which leads me nicely into why we are collaborating with the University of Ghana. They have deep expertise here as well. And again, they are always looking to make sure that they are changing up how they do things and increasing their ecosystem. I think one of the interesting things is when you've got a really healthy ecosystem and your startups are starting to scale, they need to go to other regions. And what you can't do when you go to another region of the world is assume that everybody thinks the same way, that regulations are exactly the same, that the way you speak to people works. If you go to Japan and you try to just get straight into business, it's not going to go down well. You have to have a much more, a conversation that circles around a bit more. If you go to Silicon Valley, if you haven't got their attention within about 30 seconds, yeah, it's again, so this is why it's not, I can't tell people, a founder, how they can make a success going over to Ghana or to another country in Africa. The local people on the ground who know about that ecosystem are going to be how they do that. And conveniently, as I said, we've got 7 founders over there at the moment. So to tell you a bit about what's been going on with this collaboration, it's now in its 3rd year and getting stronger every year. And actually this Friday is going to be the 3rd demo day at the University of Ghana. The Imperial College Enterprise team have been working really closely with them. about developing their ecosystem and the sort of enterprising activities they do. And it's absolutely fascinating to see this because I think one of the most special things about entrepreneurship education is we're all trying to do the same thing but in different places. And what's delightful is that you can take an idea from somewhere else and just adjust it for your ecosystem. So one of the things they liked about what we do is something called idea surgeries. And that's business coaching for when you have an idea. So little plug, students at Imperial, if you're sitting there and you've got an idea but you're not quite sure what to do next, you can come to the eLab and have an idea surgery. And do you know what? Students in Ghana can now do that as well. So that's a really nice bit of collaboration there. Last year, we added KNUST and the University Cape Coast to the partnership. So again, that's more great minds who don't think alike bringing their expertise. In 2025, we're going to onboard a further university in the north of Ghana, the University of Development Studies. And then there is going to be a conference that's going to be co-hosted, honestly, losing the ability to speak, in Accra. And that's going to have a focus on African innovation and university entrepreneurial ecosystem development for all of the partners. Right. So I mentioned that right now we've got 7 founders out in Ghana, and this is literally hot off the press. So these slides were being finished whilst my colleague Sarah was on a bus going off to KNUST yesterday morning so that she could give us something absolutely fresh. What was also particularly special was in June, we had 7 Ghanaian founders come to visit us. And it was really incredible. I got to hear their pitches, and it was just this most amazing range. Considering there were 7 of them, they managed to cover agritech, cosmetics, security, and education. That's a pretty impressive spread when you've got that few startups. And they came over and they met lots of different people in the Imperial ecosystem. They met investors, they got feedback. And there's nothing like being in London and being able to go and find out whether this is somewhere that you could expand or whether there are connections over here that could help you. And I'm running out of time, I think. So anyway, if you would like to learn more about this, please do reach out to Claire Turner, who's the head of the Global Development Hub, or Sarah Ranchef-Hale, who's the head of Imperial Enterprise Lab. And like I said, if there's anybody who wants to talk to me later about the Enterprise Lab, please do come and see me. Thank you.
Great things happening in the Enterprise Lab, as you see. And introduce our next talk.
Good afternoon, everyone. My name is Dawit Gebremeskel, a mechanical engineering student from Queen Mary University of London. Today, I will be introducing Dr. Shamsuddeen Hassan Mohammed, recently appointed as Google DeepMind Fellow in the Department of Computing at Imperial. And his groundbreaking research into computer science and artificial intelligence is inspired by a deep passion for promoting diversity. His talk today will be called Democratizing AI. Thank you.
Hello, can you hear me? Hello?
Hello.
All right. Thank you very much for the wonderful introduction. So today I'm going to talk to you about democratizing AI in Africa. In particular, I'm going to talk on how AI is being democratized in Africa, as well as how AI is being democratized in Nigeria, especially the northern part of Nigeria. So the word AI is very broad field encompassing different parts such as machine learning, AI, computer vision, natural language processing. But I know some of you might not know this term, but some of us all here may know the word ChatGPT, yeah? So ChatGPT is a kind of AI that combines language understanding, which is natural language processing, and recently also other modalities such as image generation. But the question is, does African languages benefit from the opportunities brought by these AI, such as ChatGPT? One of the recent examples that I always gave was one of the translation by Facebook AI that one of my friends went to Facebook and wrote Mensah Mukarwa. This is my native language called Hausa. It means we got a baby. And what happens is Facebook automatically translates this that my prostitute got a new baby. So you can see these show that current AI does not really understand African languages. I believe a lot of us here, background in Africa, if you can try to use your language in these, for example, ChatGPT, you can see it's speaking rubbish. So what the problem? Languages in Africa, there are over 2,000 languages spoken in Africa, and more than 100 languages are widely spoken by different use communication, and at least majority of these languages are also spoken by over 10 millions, as you can see. But the problem is these languages, there isn't any current research in the field of AI. So as you can see here, African languages are severely underrepresented in NLP research. As you can see, the number of papers in top NLP conference, African languages are insignificant. For example, you can see Hausa, the number of papers from a million speakers is 1.5. And one of the main blocker is lack of data set for research in NLP for African languages. So you can see there are a lot of data for English, for German, for Spanish, but for African languages, we call them low resource languages, meaning they don't have enough data to train models, to do machine learning, to do AI. Not only in NLP, but also in in machine learning in general. If you look at these top machine learning conferences and venues, you can see that from 2012, you can see the number of papers published in machine learning conference where authors are from Africa. And what I said, Africa, authors that, their affiliation is Africa, not those considered, authors that are working abroad, but only those that, have this. You can see the numbers of African researchers in top NLP and machine learning conferences is very significant. But due to the rise in NLP, due to the rise in communities in Africa, this has been changing. So this is a quote you can see here. Compared to other regions, part of the world where AI is driven by big corporation or strong policy and regulations framework, this is not in Africa. In Africa, AI ecosystem is dominated by grassroots movements such as deep learning Indaba and data science Africa. So you can see in Africa, it's reverse the case. It is individual, grassroots movement, support that come together and think, let's support our language. Let's move together and produce something better. You can see there are a lot of blossoming local communities that put together, that put the boundaries of AI in Africa. So you can see here we have Data Science Nigeria, which is basically a non-profit that focus on building a local ecosystem for data science AI. We have also Deep Learning Indaba, which is an annual conference and series of workshops aimed to democratize AI in Africa. We also have Makani NLP, which is basically an NLP research group that has been, even the word Makani, it's a Zulu term that means we build together. So its initiative aims to improve and democratize NLP research in Africa. Not only these, there are Ghana NLP, Zindi, which is, a competition based on Africa NLP researcher. There are also House NLP, which I co-founded, and also Array Data Science, which I co-founded to promote AI in Africa, in particular in Nigeria. But these local committees offer a lot of opportunities where they democratize AI in this. So, for example, they provide mentorship, networking opportunities, learning support, and research collaboration. In fact, my AI journey started with one of these communities when I joined Makani NLP, and there are a lot of professional mentors. And I asked one of the mentors called Savasya Ruda, who was a Googler at that time. And I asked him, hey, this is what I'm interested in, and can you be my mentor? And it was in Slack that I sent him a message, and he said, hey, why not? Let's set up a call. We set up a call, and finally, we published papers together with Savasya Ruda while he was in Google. We applied for grant research, and this is where my, AI journey started. So I urge you, if you are interested in AI, and if you are in Africa, the best place to get started is join this local community where you can get mentors and learn more from them. So this is where I, first get my mentorship called Makani. NLP, as you can see, this is one of the founder called, Jade, while she was speaking at Deep Learning in Daba, where the Makani was conceived in 2019. And in Makani, we have over now 3,000 members, published many papers collaboratively in top AI and LP conferences. But not only that, apart from these communities, there are many initiatives now to democratize AI in Africa. The first one, Google DeepMind is doing a lot of work to democratize AI. Google DeepMind has a lot of collaboration with AIMS, where they, support machine learning and mathematical science. Recently, DeepMind also partnered with AIMS to provide 40 scholarship every year for a new program called AI for Science. Not only that, also DeepMind support, deep learning in Daba every year. Google DeepMind support deep learning in Daba, which is basically a workshop and conference for AI in Africa, where I was one of the participants as well during early days, where I learned a lot. I urge also, if you are interested, try to attend Deep Learning in Daba, where you see a lot of African AI researchers. But not only that, I myself right now, I'm Google DeepMind Fellow here at Imperial. So DeepMind basically support African NLP or AI researchers, early career researchers from Africa, to offer them prestigious position, 3-year PhD postdoc position at world top best universities. So we can see Google DeepMind is democratizing AI by supporting from many fronts to see that African AI researchers succeed. Now, apart from the global African AI, one of the things that I have been doing is mentoring in Nigeria, particularly in northern part of Nigeria. In Nigeria, there are a lot of communities such as Data Science Nigeria, AI Saturday. All these communities, they are part of, they are in southern part of Nigeria, but in northern part of Nigeria, we do have lack of community that, democratize AI. And I founded this community where we teach people how to use AI and machine learning and data science. So this is what we do. We empower marginalized students, especially in northern part of Nigeria. We provide free training to data science, AI, machine learning. We provide stipend to students. We give them, internet data. In fact, we also buy computers to these students, because one of the main challenge we do have is that some of the students, they don't even have access to computer. So some of them, we buy computer for them. We support from Google as well. We buy computer for them. Our students, our fellows cut across from different, teams. For example, we have undergrad student, we have master student. In fact, as you can see here, Musa is a lecturer in Nigerian University, and he join our fellowship to learn so that he can teach his students. So our fellowship and our fellows not only undergrad, but also the lecturers at Nigerian University. Some of the success story, as you can see, this is one of our fellow that participated and won a competition, AI competition in China, and he was offered scholarship for PhD and MSc. Here you can see he's receiving his scholarship for post MSc and PhD. We also have our fellows that participated in AI hackathon, where they won a second position, where they won 800 USD. So this is one of the core success from our fellows that participated worldwide in AI competition. Right. So thank you very much for listening to me. That's the end of the talk, and I think I'm on top of the hour. Thank you.
Brilliant. Thank you. Great. Thank you, Shamsuddeen. That's been brilliant and really inspirational, and lots of useful information for students. So thank you so much for joining us. Right, we're going straight on to the next speaker, and our student introducing.
Good evening, everyone. Tackling inequality in African cities is the title of our next presentation. My name is Samuel Vasilis. For my Ethiopian audience members, that's Samuel. I'm a second-year civil engineering student in City University of London, and I'm here on the R2 Imperial program. In just a moment, I'll ask you to give a warm welcome to Professor Samuel, Agyei, Mensah. But a short introduction. Aside from having a brilliant first name, he is one of the provosts visiting professors of population health here at Imperial. He's coming from the University of Ghana, where he is a professor and lecturer in the Department of Geography and Resource Development. He is also the director of the Andrew Mellon Foundation Funded Center for Teaching and Learning Innovation, as well as leading the Building the Next Generation of African Academics project. He has many other accolades and experiences, but I'm sure he's eager to present. So please put your hands together and welcome Professor Samuel Agyei Mensah.
Okay. Yeah, thank you very much for the nice introduction. And I'd like to also thank the organizers of this symposium and those present here, as well as those online. So the title is Tackling Inequality in African Cities. Generally, there are two approaches to addressing inequalities in cities. One is a holistic thinking for the betterment of the society. So such initiatives usually come from the national level. So for example, if you talk about Nigeria, for example, this could emanate from the federal states. So public transport makes sure that everybody within the society, both the rich and the poor, benefits from this holistic thinking for the betterment of the society. The second solution lies in addressing vulnerable groups in specific locations and groups. So that will form the basis of my presentation. But to give you a flavor of what to expect, I'd like to give you a sense of the cities of Africa. And you could see that they are very diverse inequalities, but Cairo and Lagos stand out. I mean, one of the largest cities, and this is come from Habitat International's publication, and we all look forward to 2025 to see whether their forecast already holds. But I'd like to use three areas to focus on inequalities. So water, global patterns in drinking water. As we could see, United Kingdom and New Zealand, both the North and South Islands, almost 100% use safely drinking water. And what I mean by safely drinking water, which came out of the Sustainable Development Goals, is water, improved water within the house, devoid of fecal contamination and priority chemical contamination. And we could see in Africa, Algeria, quite not bad, but the challenges are mostly within sub-Saharan Africa. So this gives us a sense of inequalities in terms of water at a global level. Then coming to Ghana, Accra, which is the capital of Ghana since 1877, has really outgrown its boundaries. So now we talk about Greater Accra metropolitan area, which encompasses Tema metropolitan area, which is a seaport which was built by the first president in the 1960s and has about 12 districts. And what is interesting here is that based on Ghana's census of 2010, the extreme left, we see Tema metropolitan area having one of the highest, especially in terms of the provision of pipe-borne water. This is followed by the core Accra. But interestingly, when we move to 2021, based on the recent census, what do we see? I think Professor Templeton made mention of this. Sachet water has, in a way, engulfed the whole of the Greater Accra. There's been a wide diffusion of sachet water. So what is really giving rise to the allure of sachet water? Why is sachet water becoming so popular? The private sector has really taken advantage of the inability of the municipal services to provide what? Tap water within the households. So the allure of sachet water, maybe later we could also look at other factors which make sachet water also more attractive to the populace. Then I just made mention of the 12 districts. I think one of the challenges we have in Africa is Africa is bereft of data at the local level. When census reports are published, usually at the national, regional districts, we don't go to the local levels where the challenges, the problems are. So based on the collaboration between the Ghana Statistical Service, some of our PhD students really went to the statistical office, helped them to digitize their enumeration area maps, which were used for enumerating for the purposes of the census. And we use that data as a basis of regionalizing water sources at the enumeration area level. So enumeration area level, we are talking about 0.3 square kilometers. And using the entropy index, which gives us an idea of how households navigate, especially in terms of multiple strategies for accessing water, we came up with this map. And the one on the extreme right talks about using also the bivariate local indicators of spatial association by LISA to look at affluents and sources of drinking water. And it comes out very clear that areas that are extreme diverse, especially in terms of water access, may not necessarily be less affluent. So we have multiple scenarios. So you could have an area with diverse sources of drinking water, but it could be a low-income area. You could also have an area with diverse drinking water being an affluent area. So what it means is that in an affluent area having diverse water sources, intermittency in terms of the water flow. So they switch to other alternatives, and here sachet water readily comes to mind. Then we also have another PhD student who worked with a faculty member of the Civil and Engineering, Aruna, also looking at transport. And this also tells us that it's based on their perceptions of access to public transportation within Accra. And we could tell that most of the activities are concentrated within the core. And at the outskirts of Accra, we don't have much public transport terminals or facilities. So most of the activities, especially in terms of access to transport, are concentrated in the core area. On the extreme right, we've also been collecting air pollution data in Accra since 2018. We have a laboratory at the physics department where our students go to collect data daily, weekly, etc. So we've been able to measure sources of air pollution, both nitrogen dioxide, nitric oxide, PM. And what is emerging is that now in Accra, sources of air pollution, traffic contributes quite significantly towards sources of air pollution. So transport links in quite neatly with sources of air pollution, and we should be thinking about ways to be able to address that. So these are some of the chaos we face over here. These are transport terminals. And what is interesting here on the extreme right is during the rush hour, people are moving from the residential areas to their workplaces. In the evening, what would you expect? A reverse. People have closed work returning. So this is what you usually see during the mornings in Accra. Then there's also waste, but how do we address some of these challenges? In terms of water, one solution is the government came up with a desalination project, which uses reverse osmosis to convert seawater into potable water. So that is one that the government of Ghana introduced in Accra using desalination. And I think it's also common in most developed settings. And borehole is becoming very, 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 most urban and rural areas are using borehole because of what I said earlier, the municipal services inability to be able to provide tap water sources. And sachet water, Mike talked about it. Now sachet water has taken over. Yes, and drawing these examples from our colleagues from Nigeria, I'm sure you are doing very well. despite the challenges we all face. We could learn from Nigeria. This is the light rail, the Nigeria red rail system, which was inaugurated by President Tinubu. And I think Ghana can learn from Nigeria. And I think in 2023, President Buhari also inaugurated the Blue Line. Yes, so if Nigeria could have about 6 or 7, I think your transportation situation could be what? I mean, addressed. And I just spoke to the gentleman who introduced me. He's an Ethiopian. This is also an excellent expressway, Addis Ababa to Addis to Adama. And these are innovative ways, transportation being addressed within the cities of Africa. These are waste, and I'll just comment on Ghana's former mayor of Accra, Agyei. He received a prize, I think 2019, one of the recipients of the Bloomberg Awards, which was held in Copenhagen, Denmark. I think London received one for its zero carbon emissions as well. And what Mayor Sowa did was his ability to incorporate informal waste collectors into the collective systems within Accra. So bringing local, informal within the government's system. There have been other Zoom Lion. I understand they've now moved to Nigeria as well. They are also helping with the disposal of solid waste. And I think I'm about to end. I take inspiration from President Ramaphosa of South Africa, who said, I dream of a South Africa where the first entirely new city, talking about smart cities like what Professor Ochieng made mention of. So we have Vision City, Rwanda, and once again back to Nigeria, Echo Atlantic in Victoria Island, Lagos. So in conclusion, there are variations within inequalities in cities in Africa. An approach to address this, one is the holistic thinking coming from the national level. For example, Ghana, we have free secondary school. Secondary school is free, you don't pay. Senior high school, you don't pay. So that is from the government, betterment for everybody. But there are also localized solutions to address spatial inequities at the local level. Then development before planning, which is also very characteristic of African cities. We put up houses on waterways, and later we have to demolish these houses to pave way for free water to flow to avoid flooding. So people just put up houses without, and later we don't plan. The best strategy is to plan before what you develop. But in our case, we develop before what? Plan. So if you see a very nice, beautiful house in an area where there are no roads, there's no water, etc. And even when we have the plans, we do not implement them. It's so sad. I think I'm done.
Thank you so much. Thank you. Great. Now, Prince.
Hello. My name is Prince Agyei. I'm a software engineering graduate from Queen Mary's University of London. And last but not least, I'll be introducing the coordinator of the R2 Frontier program that we're all on, and associate professor from the Department of Civil and Environmental Engineering here at Imperial. Sunday is a multidisciplinary expert and has managed very large-scale. He's been doing that all week, by the way. Yeah, he's been managing large-scale industrial projects, engineering projects that you may be familiar with, such as the Crossrail, which is now Elizabeth Line, Future Home, the Shard, Burj Khalifa, HS2, and many more. He is also the founder of an initiative called the Creative Futures Achieving Your Potential program, and he's an important member of the Black Inclusivity Catalyst here at Imperial, and as director of the summer program that's going on now. His talk is about building bridges, so warm welcome to him.
This is how we do it in Africa. A prince introduces a king. Yeah? Right. Fantastic. Nice to see all of you. I mean, the title of my talk says Building Bridges. It's more like technology transfer. I'm going to take you through what we've been doing at Imperial College for the last 25 years and where the whole idea come from. I mean, to start with, I'm going to thank my colleagues here, Professor Rankins, Dr. Wayne Mitchell, Washington is now here, but those are the people that really, got me going. Because when I came to Imperial almost 36 years ago, I didn't see many people like me. And then I said to myself, I go home every day, I look at the mirror, I said, there must be something good about you. How come nobody like you at Imperial? So I make it my determination to make sure, one day I'm going to have a room full of people like you at Imperial. Yeah? Right. This conference is about what Black people have been doing. Then I'll start scratching my head. I said to myself, who are the people I know that really impact engineering or technology or sports in the whole world? And obviously, Professor Washington Ochieng come to mind. Then I'm looking at the medics. I said, wait a minute, there's so many of them. Do they actually impact anything? And I will give you a reason why in a minute. Okay? Wayne is already sticking fingers at me. Right? Then I said, if I start talking, I've got Faith, I've got Wayne, I've got so many of them. Which one should I line up with? I said, no, none of them. This is an engineering thing. And there's David Waboso there. A lot of you use the London Transport. All the new initiatives, all the new escalator, all the new platform in there. These guys spend, I don't know how many billions of pounds to help London Transport to where it is today. And he's a Black guy from Nigeria, David Waboso. And then you have information technology. So I think about, Nigeria is very good for that, 419s. They do a lot of tricks with technology. Yeah? If only they could use it differently, then we'll have really turned the whole thing around. Sport, Usain Bolt, art and culture, so many of them, obviously politics. I think of my brother Obama, he's really done a lot of stuff. Then I come home to the UK and I start thinking, who are these people that really, really inspire me as I was growing up at Imperial College many, many years ago? I think of Baroness Amos. Tomorrow we're going to have all the Amos bursary here, over hundreds of them. And then we're going to combine them with our school at Frontier students to really get going and start talking to each other and networking. And then Baroness Scotland, obviously, she's an Anthony. And then you have all the footballers. I mean, you ask young people these days, what do you want to be when you grow up? They talk about sports people. And Rio Vandala is one of them. Man U, which I support. And then you have David Hadier, who is an architect. He's doing some wonderful job. Diane Abbott, one of our very famous MP. And then we have Adeshola Nke, who is a writer. She's done a lot of play, and I've even acted in some of her plays. So she's very good. Shirley Bassey, fantastic speaker. Trevor McDonough. Anybody grew up to know Trevor McDonough? Yeah, I used to go home. Trevor works for ITV. And then we have Maurice Stewart that works for BBC. And I used to leave work, office, just in time for the 10 o'clock news and the 10:30 news, just because of the two of them. Yeah? Because when they're talking, they're the only one I could really, really listen to and connect to. Those two Black presenters. And they're wonderful people. And then you have, again, David Waboso. I've talked about David Waboso. And then let's look internationally. Then you start looking at Mandela, Obama, Desmond Tutu, Steve Biko, Maya Angelou, Kofi Annan for UN, Oprah Winfrey. She's done some amazing stuff. She spent all her money on charity. Jesse Owen, Martin Luther King, and goes on like that. Wole Soyinka, a massive playwright in Nigeria. He's done fantastic. It's now 90. It was 90 yesterday. I attended his birthday online. Yeah. Back to what I was going to talk about, creative futures, bridging the gap, or bridging the difference between UK and other countries. We started this initiative many, many years ago when, as I said, I came to Imperial. I didn't see people like me. I thought, listen, I have to bridge this gap. And you can see a bridge there. So when I say bridge, that's what that means. Students playing around, coming together, collaborating, creativity, and having fun. At the same time, learning what it is to study STEM subjects. Science, technology, engineering and medicine. Now we've included business as well. So we call it STEM B. And it's a fantastic day. The first year we did it, a student came out. We invited the mayor of Brent to come and speak to them. We always invite people that they know. They don't know people like us, but they know other people to come and speak to them. And then the student came out of there and he turned around to the building, one of our very famous building, 59 Queen's Gate, Princess Gate, yeah. And the boy turns around and says, I will be back, yeah. And he came back. Fortunately, he didn't study engineering. He went and studied physics. So he's one of the, and then we have so many people like that have been through this program and have applied to Imperial College and got their grades. Imperial College will not lower their entrance grade, but we can bring you up. And I said to kids, you stop playing that game for 1 hour a day, you go from B star to A star. And that's all you need. Leave that game for 1 hour a day, yeah? So this is what we do. This is how we started. And then we thought we're going to translate this to other countries. Actually, we invited the Jamaica High Commissioner to come. And he saw what we were doing. And he said, Sunday, I can't use Jamaican accent. I haven't had any drink yet. He said, Sunday, if this is good and you're doing this in the UK, let's go to Jamaica and do it. I said, no problem. Year 1, we planned it, not successful. Year 2, we planned. Year 3, I just took off. I just bought myself a ticket and I went to Jamaica. And I did a couple of school. And then the following year, they all realized it's a good initiative, and we went to all the parishes. Have anybody gone to Elizabeth Parish in Jamaica? Beautiful. Yeah, yeah. So it's not just impacting life, you actually have a fantastic time. It's a fantastic place. So over 20 years now we've been doing it. We've been transferring our experience from Imperial to other people all across the world. I've been working in partnership with companies, with other institutions, and with individuals that want us to actually achieve this thing. And these are just some statistics here. The whole thing started, there was a professor in business school, can't remember his name, he came up with this book, Think, Play, Do. Yeah? We put you in a room to think together. You play by building something or creating something, and then we will test it by see how good that thing is. And that could be for science, for medicine, or for engineering. So when they come, they can decide where they want to go into. And that initiative, that idea, was started by a guy called Rudy Page, who used to help us to form this group called Imperial as One. He was an external advisor at the time. He said, Sunday, this will be very good for Imperial. So the thing I've been doing before that, we then changed the name to Creative Futures. He actually came up with that name, not mine. And it's been building since then. We've been, normally we do it during the Black History Month. And we thought, forget that, let's do it any time of the year. So at least 2 or 3 times in a year, on a time, we run this workshop where school children comes along and basically spend a day at Imperial. Now, you've heard medics talking about malaria, talking about sickle cell, talking about COVID-19 and vaccine and all that. And then Professor Templeton talking about tiger worms, and Washington talking about sustainability. Right. How many scientists or medical people in the room? Raise up your hand. Engineers? Yes. Right. So if I say to you that engineers can save more life than medical doctor, will you agree with me? If you disagree, say why you disagree.
I agree.
Oh. For the first time, when you say you agree, that's unusual. All right? So why do you agree? Say that again, Professor.
Vaccines have the biggest public health impact.
Yes, well, engineer.
Okay.
Engineer.
No.
This is my presentation, Sarah.
It was your presentation.
Yeah.
Which building are we in?
Oh. Okay, right. Skempton was flooded.
Alexander Fleming building. Alexander Fleming, Imperial, right? What did he invent? Discovered penicillin. Right, this is...
And what machine did they use to discover penicillin? What machine did they use to produce penicillin? Who created machine that they used to to produce penicillin.
Remember this fact. How many people in the world? No, come on, let's just get this. How many people in the world?
Yes, yes.
How many people in the
Thanks,
world?
Mary.
How many people in the world? Okay. Without penicillin, 3/4 of the world's population would not be alive today.
Without drinking water, they'd all be dead.
Thank you very much. Thank you very much. Thank you very much. Sarah, please sit down. Let me finish.
Okay.
Right.
We're used to this argument.
No, we do this all the time. There's actually a colleague in physics, Mark Richard. He's worse than Sarah. He will stand up and punch me. Right. Why? Why did I say that? As Professor Templeton said, we provide clean water. And it's just not just clean water, clean and healthy water. So you don't end up in hospital and some people are giving you some diarrhea stuff. Yeah? Okay? Roads, cars. You're driving your car, you put your foot on the brake, the car stops or not? Majority of the time, it does. A couple of aircraft crashes, yes, that happens. But how many people do they kill? Not that much. And we provide energy. Look at your room, your phone, your life will not exist without all this power that we provided. Yeah? Tell me who can do without their phone in a day. Yeah? If I leave my phone at home, it's as if I'm nobody anymore. Yeah? I have to go back and take my phone. The only thing we have trying to find solution to is flooding and other disaster. We're struggling with that, and that's where we want to train the young minds. Come up with a solution. There is a solution somewhere. Yeah, that will make sure your future is secure if you can find that solution. And one thing that we're very good at. Anybody did number 1 today? Did number 1? Where did you think that water went into? The water that when you're number 1, yeah? Yeah, through the drain, yeah? Not quite. Professor Templeton is there. Not just number 1, it takes number 2 as well. Yeah, you saw him collecting number 2 there with those tiger worms. Yeah, so we're very good at cleaning up your number 1 and giving it back to you safely so that you don't end up with these guys. Yeah? And then number 2, we turn it into fertilizer, we plant your fruit, you're eating all your fruit, they go, oh yeah, this is very juicy. It's your number 2 that's doing all the work. So, Professor Templeton, thank you very much, yeah, for amazing work you're doing. Yeah? And that is engineering. Let's get back to creative future now. Yeah, so these are the kind of things we do with our students. These are things they don't teach students in schools. They teach you maths, physics, and all that. But how to think critically, you don't get it. How to be creative, collaborate, communicate your ideas. People who are actually putting their ideas on the paper and communicate with their team are the best. Because when you get out of here, out of university, computers, so you just put a number and they press a button, it gives you an answer. But how do you know what to put in the computer? And how do you know whether the computer gives back to you is correct or not? You've got GPT, whatever, giving you rubbish. How will you be able to tell that's the right answer? So we want to create those minds, those fantastic creative minds. That's what Imperial College is all about. And that's what we're giving back, not just to you, university age, but to young ones. You see them all over the country. Those are all people coming around to do outreach with me. For the last 2 weeks, we've been doing it. And it goes until the end of this month. Then I fly to Ghana, to Nigeria, to Kenya to do the same thing. My summer is beautiful. So if you want to join me, come along. So that's what we do. And as I said, this 4C, this is what I call the 4C. These are the way we work. So when they come in, they think they're going to be doing maths, equations, and all that. No. How do you use those maths? How do you use that equation? How do you use that formula? That's what we teach them. And how you then collaborate and explain yourself to the real world. And not just for the young one, we are graduates or undergraduates, PhD, and even professionals have been on this course, and everybody have gained from it. Yeah, and this is just some of the pictures of what we've been doing all over the world. Young girls making bridges out of straws and glue and sellotape, and you could the smile on their face. The funny thing with these, when they're testing it, you should see these guys. I mean, I know they're religious, they believe in God. They will be praying for their other team's bridge to collapse before theirs. Yeah? Passionately praying right there. And I thought, calm down, it's only a bridge, it's not going to collapse. Right? So that's how far they go to basically make sure. And we have fun. We get them to do paper plane. Everybody knows how to do paper plane. But there is a technological way of doing paper plane to make sure you can fly from the back there, right here. Yeah? Just by learning how to do it. And they all do. So they go back to school, and everybody is doing paper plane. And that was 2019. And the whole thing started from doing classroom with my undergraduate student. When I first joined Imperial College, I said, listen, we're not doing enough hand-on. Let's introduce something that people could actually do hand-on. So we get the student, again, working in teams to build a bridge. And that's a small bridge there. And we put some weight on it to see how strong it is. And then we'll take them, this is the London Eye. The same year London Eye was built. We get a student in a classroom. We're working with a colleague there called Chris Weiss, very famous engineer. Get them in a classroom, and they work in team to build London Eye with A4 paper, tape, and string. And they actually erected the same way the London Eye was erected. So before London Eye was built, some people were already doing it. She's scary enough to kick me off now. All right? And then we move on and get into civil engineering, as I call civilized engineer, and get our students to go on site and actually build real stuff. So you could see the progression from 2002, 3 to 2005. That same bridge right there, we are now scale it up. And look at how many people actually stand on it. There, we can only take one person. We couldn't risk it. But now, the whole team can actually stand on it. And then for the student that comes along, I give them this example. Water tower. You've seen that before? Come on, build me a water tower. And if you don't build it right, this is what happens to it. It sinks, the leg buckles, all the wind blow it apart. So they all build one, and then we load it to actually see all those failures in those water towers. And that changed their mindset. So they go around the country looking at water tower. Yes, I know how that works. I know what's preventing it. It's got the cross-bracing, the X factor, and all that. So, and then we get them to do a bridge. This is a schematic of a bridge that we give them. But number is really amazing. From 2005, I think we started. That's it. 2005, you see the number growing, but you could see a number here. Guess me what year that is. Anybody can tell me what year that is? Yes, yes. I mean, COVID was bad, but for us, COVID was fantastic. Yeah? We developed a new way of doing this thing. We went online. We have various versions of creative future. We have, we want to be a millionaire version. We have so many different, and the people that actually help us with this, you guys are going to see them tomorrow. They're going to present. It's called Young Guru Academy. Yeah? They've been looking for a way to really impact young life, and they came and partnered with us. Royal Academy of Engineers gave us some money to train scientists and engineers to do outreach. And we finished the training only for them to go out there and actually practicing COVID attackers. And then we just translate everything online. And then we won quite a few awards that year. The president gave us an award, but you could see the number there. It's more than all of this added together. And we're still growing. This year, the number is just crazy. And this is just some of the pictures of students who've been to Creative Futures, and they're doing so well these days. And this is some of the bridges. When they test it, even I get very excited. Yeah? This is the guy that took us to Jamaica, and he didn't pay my accommodation bill. And I like my selfie, as you all know. Every time people come around, I love my selfie. I can do myself with my eyes closed down. And then you get reward. You know, the director at the time, 2006, I think this was, the rector came to one of the events, and he saw that, and he was so impressed, and he gave us an award. And I've asked a few more awards. This is Prince Philip there. May God rest, may God continue to, may him continue to rest in peace. This is a couple of years before he died, and he was reading the magazine, Royal Academy magazine. He said, oh, student going on site, building something. No, I don't believe it. I want to see it. And he came on the Queen's birthday. He came to the site, said, oh, from Sandiram. He said, let me just go and see what they do. He was going to be there for 50 minutes. He spent about 45 minutes there. He got so excited of what we're doing. And he's just talking about it actually gave the whole constructionarium amazing boost to the extent that other universities now want to join us. And we got about 26 universities now even one from Texas and one from Italy, join us every year to make sure they go through. And this is my undergraduate student here. Yeah, this is the bridge they built in 1 week, 20-meter span, and this is me. So I have faith in them. I have so much faith in them that they build it, you can stand up. The same kind of principle that the young kids do in the classroom with the straw, and the same principle they use there, although more materials. And you can see the outcome of that. So students from this, they live here, they go and set up their own company. They don't want anybody to employ them. They develop that to say, yes, I can do it. I can know how to manage my team, how to manage my material, then I can go ahead and do it. This year we have 10 groups. We have 2 cohorts. Because of COVID, we were lacking. We have 2 cohorts, and we were able to deliver 10 projects in 1 week. So that's how I bridge my bridging, whatever the title was, yeah? Bridging the creativity, and how I'll make sure engineers are the best in the world. So thank you very much.
Thank you, Sunday. And before I forget, I do just want to say thank you to all our speakers today. So I think we just have a big round of applause to say thanks to all the speakers. So I'm just going to open it up to questions now. If anybody has any questions for any of our speakers or anything else, or... I know this, it's been a lot. It's been a lot.
There's jollof rice out there. You don't have question, you're not having jollof rice. Nigerian jollof rice, by the way.
There's no jollof rice. There's no jollof rice.
Yeah, there's one there. Joshua?
This is quite a quick question. It's to do with admin. So you mentioned, I think it was Angela who mentioned the AIMS program, and that in 2003 you worked exclusively with Rwanda, or the Rwanda campus. 2004, I said 24, it's Ghana. Could you do you know who you work with in 2025, 26, 27, or are you seeing how it's going?
I don't okay, thank you. Thank you for your question. So I do not personally work in that program, and I also don't think that anyone knows the answer to this question at this stage. As I mentioned during my presentation, this is a relatively new relationship, so specifically this program with AIMS. So I think everyone agrees that we very much want to develop it, but ultimately we will see how it goes and what sort of funding we have access to. But I think, genuinely speaking, there is interest, as I've said, in taking this forward as much as we can.
Great, thank you so much, everyone. So I think we're going to take all the questions into the networking. And just to say, I've got the bottle opener, if anybody needs it. I bought one. So please join us. I'd like to say thank you to all those people that have joined us online. We really appreciate it. We really hope to continue, extend our collaborations and partnerships. And yeah, I think that's it for today. Did you want to?
One more thing.
One more thing.
For now, I've got my mic. Right, I would like all of us to please thank Professor Sarah Rankin.
Thank you.
All these initiatives that you see that we do for black people and youths and all that, she's behind it. I'm the technical end. She's the back end. And if you are the back end, the technical end will never happen. Myself and Wayne do the medicine, I do the engineering, and then we have another colleague that do the science. But in terms of getting the funding to be able to do this, she goes and have the argument with Mary, yeah, without us involved. She just email Sunday, yes, we've got it, another year going. We've been running this for 3 years. Obviously, before that, we've been running it by ourselves. Yeah? She will use her credit card to buy pizza, when we'll make sure you got plenty of drink, Or if you run an event and there's some drink left over, we put it into my store and we use it. That's how we'll be managing. But since Sarah, I've found a pot somewhere, our life is so easy. So you guys are very lucky. So help us to thank Sarah about it.
Yeah, and obviously thanks to Imperial and UKRI for that funding that has enabled this to all happen and hopefully continue to happen and build over the years. So this is a great start for this being the first Africa Innovates event. We hope to continue it. Would you like us to do this again next year? Yes, I couldn't hear that. Okay, great.
Yes.
Okay, brilliant, thank you. Right, let's go and have some food and some drinks and continue our conversations. Thank you for joining us today.